change to some easier topics like statistical learning or supervised learning. For most of the cases, I think it will be very useful for our data analysis to prediction or classification different type of the task that we'll meet on daily basis, either for learning, the statistical learning, or to use in a real world scenario. They are quite useful. This is one of the I would say test I would do from every now and then. It's called comparing the models. As you can see, first of all, I show you a summary that usually when I compare the models, different models, first of all, I need to know the data. Today, I'm going to show you the data set from the Kaggle. Is a credit card default data set. I know it is very intuitive. Most people use such data set to train a model to predict if the client is going to default next month. It's very useful, but the first step, you need to know the data. You need to know every column, what it means. I'm not going to show you here just to keep the content as concise as possible. Second of all, you need to do standardization. You need to separate numerical and categorical data. So numerical data, you can calculate, just standardize to do not let the size or the sheer volume or the amount of a variable impact the model too much. About categorical variable, the common practice is to convert it to dummy variable. During my test this time, as you can see here, in the compute side, first of all, I count mainly the runtime of each model, how much runtime it will cost to train the model. So like the k-means neighbor, decision tree, random forest, and so on, I use a very simplified parameter setting, and most of the code are generated by ChatGPT. I already checked it. It seems good. I suggest you also to do this test because it will help you to understand how much compute each of the model will cost. Then about the complexity and the interpretability. For example, like complexity, ChatGPT gives me complexity, is like a complexity measure. I have not yet 100% matched them to the very rigorous academic representation. But about the interpretability, I think it's quite accurate. For example, like a linear regression and logistic regression, you can interpret the change of the independent variable to the dependent variable quite easy. But about the neural network, I believe you already know that we have multiple layers of neuron. We have activation function. There are so many changes, so many detailed calculation inside the model. It will make it very hard to explain. And also for the transformers model, like the large language model, the structure is very complicated. We cannot easily interpret such model. And then if we are going to look at the number of parameters, you can see like a neural network has very, very large parameter sets. Of course, you can arbitrarily reduce the size of the number of parameters, but in any way, the runtime to get the similar results will be the highest for neural network. And for random forest and gradient boosting, you're going to have also much higher runtime relative to the simple like linear regression, logistic regression. Then, whenever you want to go deeper to analyze each model, I really suggest to get into the overfitting part first, because when you have this model, your objective is to catch the more generalized pattern to apply to the neural case, to the test data which you have never seen, the model has never seen. So whenever you use the existing data to do the train and the test data, to separate them and to fit them in the model, whenever you see that train accuracy is higher than test accuracy, note that overfitting is present and you need to address it actively. Today's code, I'm not going to dive very deeper to the overfitting resolving issue. I'm just go through it quickly and show you some of the sample code that ChatGPT gave me. The final point is the solution of overfitting. As I said, you need to check deeply about each model configuration and to see for cross-validation, regularization, and hyperparameter tuning could be suitable for resolve this issue. About cross-validation, it is to get a better estimate of the model's performance. I think the more common approach of the complicated models is to introduce regularization and hyperparameter tuning. Now let's go back to the code. So basically, in order to run code, you need to install some packages about pandas, numpy, skitlearn, matplotlib, and seaborn. These are very common libraries. Then about Kaggle, I want to mention to you, if you want to use a Kaggle package, you always need to have the active API so you can download directly. I did not put much time to configure this part, but I leave it here just to remind you that there is a possibility to download the dataset directly through your code, but you need API key configuration. Then Plotly is for actively or dynamically display my data, all the different metrics that I need to evaluate the data and model. MB format is actually part of the package that will interact with Plotly, but I did not get a successful result, but I leave it here. So whenever the system says error about this package, try to install it, reinstall it. If it does not work, check documentation. So about the several steps before the final code, of course, I interact with the large language model. I try to teach it to find the very detailed problem to refine the model. For example, I already have the structure, I have some code written, but ChatGPT cannot recognize the necessity to transform the numerical data or make certain categorical variables as dummy variable. So it is an iterative process when you talk to large language model to refine the code. But in general, these, I would say, quite simple models about regarding the model design, they are quite simple. The zero shots or the accuracy of writing the code with a large language model will actually help you to improve the efficiency of writing the code. Okay, let's go on. So first of all, we need to read the data. Okay, about the first two lines, if you do not have the Kaggle API, usually it does not work. So I actually manually downloaded this dataset and save it in the data folder here. So I use Finder to directly read the dataset, of course. Then I prepare the X variable and a Y variable based on my need, and also to transform the numerical variable, categorical variable as I need. So basically you need to pay attention to all of these details. You need to understand your dataset so you can work better on it. Then this part about showing the correlation matrix is not 100% necessary, but if you want to visualize the correlation between different variables, I suggest you to do it. But remember here about the sex, education, and marriage, because they are categorical variable, putting them here is not 100% necessary. I suggest you to delete it. But if you put here, just don't refer to it as main issues or the main influence to the dataset or to the model in a numerical sense, I mean. Then we can see here, we actually split the data to training data and test data. Okay, this is a common practice. Then define the evaluate model function. Actually, it will record the runtime, which I personally would like to check every time to see each model consumes how much runtime, which will refer to the compute consumed. And of course, we are going to use a different function to actually to train and to get the different metrics which we are going to display later. So each of the functions, each of the equations will actually help me do that. For example, this one is going to help me get the train accuracy matrix so I can display later. And in the later part, of course, ChatGPT was helping me to add such if condition passage to actually capture some of the information I need, like number of parameters, coefficiency number. The size means that how many coefficients used in the model, how many layers, how many features, okay, and to actually summarize these information so I can use later. So eventually it will return all these metrics so I can compare later. So about the model definition part, because we already imported different packages, actually most of the models are ready. I mean ready because we already have these packages. We can easily write in the code to implement them. As I said, like the different parameters in different function, you are free to change them. Or if you want to do further experiments, you can use a function to change it. For example, each time you change it by 10 units or 1 unit of each parameter you are setting here to see the difference. Okay, sometimes I do it just to check the different model performance. Then the results will be will be collected. So for the later comparison, and the results are going to be set or be saved in this data frame. So in the later part about the results data frame, I use different strategy to plot them. For example, this first one is quite intuitive plotting. I observe that for most of the model, they have the overfitting problem because training accuracy is higher than test accuracy. And I can also see that although the neural network has very large parameter count and also consumes the highest compute, local compute resources, but its performance is not very, very high compared to other models. And we can also see here mean squared error is a matrix to see the diversion. I would say the diversion from the actual value to the model value. And we can see that For some models, it does not have such metrics, so the system cannot produce it. But whenever we see if the test MSE is higher than the train MSE, this is also a way to see that the model is overfitting. To the later part, of course, this one was the same graph. Of course, when you try to visualize it, you can change the size of the graph, but at this moment, I cannot resolve the issue of the display because you see gradient boosting. The display of the chart was not very good because you see the I think is the test accuracy bar is quite out of range. But do not worry if you meet some problem like this. I'm going to show you some solution like Plotly library. And here I did introduce the 3D plotting of the results to see the test accuracy, which I care a lot about, and the runtime, and in the z-axis we see the mean squared error. From here, it's not very easily to observe, so I would recommend you to use Plotly. So first of all, let's try to display the 3D graph of the different metrics. If we run the code, I'm going to see here. Okay, so actually it jumps into this HTML file. I think it's very easy to visualize, and you can change the different data you want to visualize. For example, I want to see train accuracy and test accuracy. Okay, so I have this pair of comparison about the train MSE and the test MSE. Okay, so in a dynamic way, it will help you to visualize better. However, I did not change much of the code. The original code generated by ChatGPT stacked them together. I would suggest you to change them to make them separate because they do not have a stacking relationship. But if you are going to see only pairwise comparison, this version is enough. So let's see here. This is going to show us the runtime, test accuracy, mean square error, the 3D plot. And here we go. You can see here, when we actually rotate the 3D display, you can see the position of different models. Of course, if we only care about the runtime, we can see here we have a neural network is way further away than the other models. And here, if we only care about the mean square error, you can see decision tree actually has the highest mean square error. I think this is training mean square error. You can check the code and change a variable to compare. Now about the complexity summary of the models. These are generated by ChatGPT. I think most of them make sense. The only thing I'm not sure about is about the equation for complexity. I think it is utilizing the number of parameters and the different variables to display. But about interpretability, it's intuitive for different model. Of course, we find it easier to interpret or harder to interpret. As I said, the simpler it is the model, the easier you can interpret them. About the last one, let's see the chart. Okay, actually, this one is about runtime, number of parameters, test accuracy. Okay, so if we look at here in this way, the test accuracy does not have a significant relationship with number of parameters, because you see here in the group where we have the highest test accuracy, actually most of the models have less number of parameters than neural network. Okay, and we can also see in this way, in the runtime sense, neural network is the slowest one. So this is part of the reason that when we train a huge neural network, it will cost a lot of compute, and most likely they are not suitable to run on local machines. Then about the runtime and test accuracy, see it in this way. Just 1 second. So most of the models has a similar runtime consumption, but about the test accuracy, it don't change much. But you can see here, gradient method, gradient boosting, has the highest test accuracy, and the runtime is quite reasonable. By reasonable, I mean because we have a relatively small data set. When you have a huge data set, you need to introduce different strategy to handle such huge data sets. I wish in the future we could discuss some of the implementation of the methodology to handle large data sets. Now about the final part, as I mentioned before, overfitting is always an issue. I would suggest you to pay attention to it, and if you want to address it, use different methodologies, do more tests to understand which one is better to actually. I think models are like animals which are not contained, because if you are not contained, you may go to a very long range and you are not confined by your target. Regularization is like a way to actually make sure that the animals know their target, know their prey, so they could focus their energy to that target, to that objective. So this part I'm not going to go any deeper. As you can see here, if you interact with the language model or with your domain knowledge, you can design further code to actually test the different modification, either by the hyperparameter or some regularization terms to make the models work better. So today's introduction or a sharing of experience, I'm going to stop here. So just a quick wrap up. I would suggest you to test different models to deeper the understanding of the model's compute consumption, accuracy, overfitting problem, and how to um, test them repeatedly and to use them in your real world data set to actually see if they work well. And about the overfitting issue, remember, I'm not introducing you now because I don't want to complicate the focus of this video, but I do recommend you to pay great attention to it. It will make your model more balanced if you address the overfitting issue properly. Okay, so thank you very much for the attention. If you like my video, please share it. Please give it a thumb up. And if you like my channel, please subscribe. If you want to discuss anything you like, you have any suggestion, leave a comment. And I'm going to see you next time. Thank you very much. Bye bye. Hello everyone, welcome back to my channel again. Today we're going to explore some additional functions, or we can say advanced functions of OpenWeb UI. This is a tool which I introduced in some previous videos. It is a tool that will enable you to run large language models locally. You can link to the cloud-based large language model inference point, or you can link it to local Ollama to run it. Before we start, I would like to mention to you several logistics that we need to pay attention to. First of all, we need to have the Docker installed in our local environment, because I'm going to install this application OpenWeb UI inside of the Docker and run it with the Docker. You also need Ollama to be installed to your local environment, or install Ollama in Docker environment. At this moment, since I tested the Docker version of Ollama, the inference speed is hugely impacted. So I'm going to use the local version of Ollama. Now, let's first install the OpenWeb UI. We can just copy this command. If you want to use other options, it is totally okay, but I just want to run OpenWeb UI with NVIDIA GPU support. I just wish that my inference speed would be faster. To run the command, you need to open your CMD, just copy, enter. It will make sure that everything will be installed. In the meantime, we can download the Ollama for Windows. In my case, it's Windows. In your case, if you have other operation systems, please choose accordingly. Now Ollama is successfully downloaded. We're going to open it and install it. Installing Ollama is very intuitive. You just click install and the program is going to run and set up everything. Now we have both Ollama and also the OpenWeb UI Docker version installed. Now, first of all, let's check Ollama. Now, Ollama is okay. Let's check the OpenWeb UI. Yeah, it is also installed properly, and then now we can open the port to log in. We just click this port, and here we go. No matter if you have installed before or registered before, you can always choose to register again. Okay, you can try log in. If login is not okay, you can just sign up again. I'll just insert new information and create the account. Then here we are. Now we can choose a model. Now you can see now the model is not shown, which means that Ollama is not properly started. So we just go back and we choose Ollama serve. Okay, and let's check if we have any models. No. So we just pull a model, Llama 3.2 1B. Let's put this model because it's a small size. We can try some very fast test. Okay, now we're ready to go. Let's check Ollama list. Yes, we have this model. Let's try to refresh it. We can see this model. Yes, we have it. Now let's try to ask a quick question. Let's say, write me a simple Python code to display line graph. It will take some time. Yeah, but the speed is okay. As you can see here in the OpenWeb UI, now there is already a very beautiful display of the code and you can run the code. But if in your version you cannot run the code, I'm going to show you there are many functions and tools where you can install and try them. Let's try this one. We run this code. You're going to see here is a black box, which is the execution of the code. You're going to see this is the results. It is pretty awesome for you to try some small and sample code. Let's just say try another case. Simulate movements of 3 stocks and show their technical buying points. I'm just giving a very general description. I'm not specifying which technical strategy to use. Let's just see. Okay, now we have this code simulated 3 stock price with random function. Now let's try it. Run this code. Yes. Now we have 3 stocks simulated. Here, however, the second one there is no result. I believe it's because the code, the range of the time is only 3 days. Let's just say increase simulation span to 200 days. Let's see. Okay, now we have the code. Let's see if we can simulate buy and sell signal. Okay, so now we have some error. Let's try to see if the model can actually debug this error. Okay, the problem is about the data frame should be the same in the same length. Okay, it seems that it has solved this problem. Let's see. Yeah, and you can see here are some buying and selling signals. Show them in the trend line graph. Yeah, let's try it. Okay, there is a problem. Let's see if it can debug. Okay, try this code. Okay, still problem with the array length. Let's try. Okay, so it seems that it cannot debug the issue. Okay, let's just try to simplify the code and retry. Okay, so it seems that there's still this error. Um, let's try something simpler. Sample code to show bar chart. It still takes from the previous prompt and the conversation, so it still focused on the closing price simulation. Anyway, let's see if we can have the graph display that we wanted. Okay. Anyway, let's just try forget previous conversation, show a sample code to print bar chart. Okay, it still takes some of the chart memory and show here. Okay, so now since the model has specific limits on the capability, I'm going to stop here. But as you can see here, the most important thing that you can use now with OpenWeb UI is if you are locally testing some of the models, you can just try to write some simple code without using too many logics or packages or outside APIs. Usually it should work. But if you need to have more interactions with the other environments, it is not very convenient because the best way is that you copy it out to VS Code or to Colab where you have the packages installed. Because here, if you try to install the package, it will not work. So now let's try other cases. Now let's go to the OpenWeb UI community page. In here, you can find some new functions, new tools, and many other content. So now let's just try this tool. It's called Stock Reporter. Okay, this tool will do a comprehensive stock analysis tool that gathers data from FinHub Free API and compiles a detailed report. Okay, in a more prudent way, you should check if this code is safe or not for you to run, because some of the code may not be very stable or may disclose your personal information and so on. So one of the quick way is to copy this whole text, and let's try to ask a large language model is below code safe. Need to select model here, is below code safe. See, appears to be a part of an API client. Okay, let's ask is it safe for me to run? Yeah, authentication is a hard-coded API as expected because the author already mentioned it. Input validation, no checks of the input parameter. Okay, this is only error. Potential risk, data exposure. It will not touch my personal data, but I think it's fine. So at this point, I think it's fine. Yeah, API usage limits seems okay. So in general, I think it's okay for me to try. I'm going to try it. You just click get and it will import to your OpenWeb UI. Okay, I'm just going to log in again. Because the default mode, it opened my Windows browser, and here I'm still in Chrome web browser. There is no difference because you can run them simultaneously. In here, now I have opened. I try to get again. Import to web UI. You see here in tools, you have these tools imported. Let's just save it. It will ask you to confirm. And the reason that I did the security check is because here you see the warning. Please carefully review the following warnings. Okay. Tools have a function calling system that allows arbitrary code execution. Do not install tools from sources you do not fully trust. Okay, confirm. Now we can see here the tool is properly installed. Let's go to the model part. Let's see if we can assign this tool to the model. We can select the tool that we want to use here. Save and update, create a new chat. Let's try to select stock reporter and then save and update. Then let's come back to the chat page. Let's refresh, choose a model, and we have the stock reporter tool up and running. Let's select it, and let's say report on AAPL analysis. We are seeing that there is a tool calling on this tool. Let's wait for a while. Let's see if it works. And you can see now there is already a response from the large language model. So I doubt if the renewed information could be incorporated into the result because the inference is already stopped. Well, after waiting for a while, I think it's not working properly because the latency is very significant. You can try it also on your machine, but for the moment, I'm going to stop this test on this tool. Let's try to find another tool. It's called code execution. You can just check here if you can find it. Yeah, you see here, this is a code running function where you can let the OpenWeb UI to run your code. But as I showed you before, I already have it in default mode, so I do not need to add additional tools or functions. But if you cannot find it in your version, do remember to try these tools to make sure that you can run the code in a very fast way, just to test some of the code that's generated, or you want to get some explanation and you want to test it right away. Install this function, you import it to Web UI, of course, but now you see you are not in the tools part, you are in function part. If you are okay, you just save this code. Please do remember to do some security check. And now we have it in functions. You can enable it or disable it. It's based on your choice. Let's see how we can turn it on. So now let's activate this function or the subcategory as action. Let's enable it and let's refresh the page. Yeah, it's enabled. And we'll refresh our chat interface. Choose a model, and now I say write a simple sample code to display bar chart. Here we go. We have this bar chart. You remember in default mode, we already have the run button here. We can run this code. But since now we have the run code action, we should have a function here. Now we do not see it. Let's see if we can refresh and see it again. No, it's not here. Let's try to disable it, see if we see anything change. Nothing changes. So I believe it could be that if we already have the default mode, we have the run button here, we do not see additional run code button, even if we activate this function. Okay, so I'm going to stop here. If you do not see this run button, try this function. And if you have any question, let me know. So now let's try something new. Of course, in here, as you can see, we can choose models, okay? And if we choose a model, it will allow you to set up the system message for a model. And if we choose prompts for the information, yeah, document information extraction, yeah, this is just some prompt format created by users. If you think it's useful, you can just save it. Okay, and also we can have tools and functions, as I already showed you before. You can search here. So now let's try the prompt. Okay, like Python expert. Okay, when you get the prompt, it will be saved here. And how do you activate it? You just go to the chat and you insert sign. It should appear. Okay, let's try again. Yeah, you can see here, the prompt is here. You click and ready to be sent. You see here is the example, well-structured Python code. Here's to PEP 8 standards and with stock string very well structured. Let's try to run this code, see if the system could allow us to get some results. It's not bad. It's only the color we have some issue. And we have bar chart. So it works well. Now let's check if we could have something else to test. So let's see again about tools. There is a tool about enhanced web scraper. I think it could be useful. Let's try it. Yeah, save the tools. Okay, let's just go to a new chat, and we need to assign the tool to our model. Yeah, so let's refresh again, choose and see the tool. We have the enhanced web scraper tool, but it seems that it is not yet here. Let's try to deselect the others and just highlight the only one that we are caring about now. Let's see. So the update sometimes takes some time. Let's just restart a new page, choose our model. Yeah. So sometimes the refreshing speed is a little bit worrisome. Let's just try to actually delete these tools. Let's see if we can resolve this issue. Okay, yeah. Now let's just try. Before we do anything, let's just see what it does. Improve the web scraping tool that extracts text information using a GNA reader. Okay, and let's see. Let's try to scrape a linear regression Wikipedia page. Let's see if it works. Wow, this works very fine and gives you code example, and we can run the code. It's about the prediction of a Y label. It looks okay, and there is also the R code, but as you can see here, we cannot run R. Usually we can run Python, but in general this works fine. There are some tools that we cannot use successfully. I'm not sure if this is a problem about the model or about the tool. Okay, it could be both. Now let's go deeper with this current application of this tool. Let's try here. Ask a question. What does it mean? Okay, so it actually allow me to ask a specific question or choose a specific part to ask a specific question and give me an additional response. Yeah, let's see here. Can we do this? We can also say explain. So it will just explain this part. Looks okay. And if we go to ask part of the code, can we do it? Yes, we can ask it to explain. However, whenever I use such function, it seems that the chat after this part will be erased and you are going to start a new chat. Well, in general, it looks fine. Okay, we can get additional insight, additional information, additional explanation, and so on. Okay, so far we have done some tests about different tools and functions. It seems that the web scraping tool is working fine. Now let's see if we can test some other functions. Let's try this artifact. Yeah, artifact v2. It is inspired by cloud artifacts. If you have already used the cloud model, it actually can render some of the React application or HTML in a very good way. Let's try it. So we just add it into function, just confirm, and I think run code we do not need to use now. We just use artifact, and let's try. So basically, I would say design a good looking blog HTML page. I need to choose my model first. Design a good blog page. Okay, in HTML. Should have said in the beginning. Now we have the HTML code. And let's see if the filter can actually render this HTML directly. Okay, so we have the artifact up and running, but we do not see anything rendered. But if we go here, as you already see, even without this filter, let's try to delete it. Delete everything just to make sure that there is no overlapping with some potential issue. Okay, the scraping tool we can leave it there. Let's try. Okay, refresh this page of the chat. Then we click here artifacts. Okay, there's no HTML content found. Let's try output only HTML. Output only HTML. Here we have HTML. Let's see if we can show them in artifacts. No. Okay, now let's try the function again. Artifact2. Save it. Let's also check our model specification. We need to activate artifact. Let's see. Let's try start a new chat. Let's looking blog HTML page. Yeah, now there is a button called run. Let's try it. Okay, so this does not mean we can run the artifact. This is the same as previous code running, and we still do not have any chance to render it. Let's try artifact. Now it still says no content found. Yes. Let's try to see again. Function should work. Try refresh again just to make sure. No, not working. Okay, no, it's not activated. Sorry. Now let's activate it and refresh our chat. We should have it. No. Okay, let's try again. Sample HTML. Okay. Now it seems to be working, and let's see how can we try it. If we go to artifact, yes, now we have it. So basically you need to install the filter, activate, link to your model, and then you can have the rendered HTML display. So let's see if we can have something more complicated. HTML to show the whole process of transformer dynamically. Well, I tried it in cloud model. It was okay. Now let's try here. Okay. So we do not necessarily need to close the window. We can just wait. Well, it seems okay. Let's say input value 12 and let's submit. Okay, it also downloaded the HTML in my local machine. Well, nothing shows. Improve. Yeah, it will refresh automatically. Version 2. Okay, input value 12, results 12. 1, result 1. Yeah, not working very well, but in general, we have an idea. So, I think if we use more advanced frontier model, we can have better results, of course. But now I'm just going to show you what I'm testing in my local environment. And it's totally free, so you can do as many tests, as many exploration as you want. Okay, so now we have figured out how to use the filter. Okay, now let's go back. At this moment, there is one more thing that I want to share with you is that we can see here there is overview. You can see it's like a workflow, dynamic workflow. It is very nice. If we choose the other, for example, this one, chat we had, we can see the whole process, right? And also let's try something longer like this one. We can see actually the conversation has been going for a while, and we can also give it a like. This dynamic display is very interesting. Let's try deep LX translate. Let's try this one. Okay, we have done. Let's go to models. Yeah, let's cancel the others. Let's save. Okay, let's try. Choose model, and let's see this function is called translate. Okay, translate promise die to Chinese. It's very interesting. Actually, it automatically translates the information to my native language. Let's just try another one. Scrivermi una lettera. Okay, I'm just asking the model to write me a letter. It says it cannot create any risky words. That's in Chinese. Looks good. Let me try write a short story. Let's see. Keeps on writing memory weaver. It translates the response instantly. And it is actually using the deep LX. I think the quality is good. Okay, let's try more tool to transcript provider. Let's try to say YouTube video about machine learning. Okay, this one. Let's copy the link, come back, and let's see. In the meantime, okay, clear. So we go inside and copy this one, copy this link. Okay, so it wants me to insert a title. Let me try. I'll determine YouTube video ID. So where is the video ID? Let's try again. So let's take a look at the tools we have. YouTube transcript provider. Yeah, so it actually needs something. Okay, I am talking about the video in free code can summarize the video. Well, it looks okay. How about the video of NG? Yeah, show URL. Okay, so summarize latest YouTube video on US election. Okay, not working well. So you can see there are some limits, there are some applications, possibilities where you can explore. So I'm going to stop here. So now one last thing, let's try this code writer. Let's try to get it actually impose the system prompt. So it is not actually a new model. It is actually using structure designed system prompt. Let's try here. Okay, Python code to get a to analyze APL goes straight to the problem itself, and there's no additional wording here, right? Yeah, of course, this is the issue I have not yet debugged. It's about the installation of the packages in the code environment. Now let's try another one. Sample code to show all types of data visual. Yeah, seems okay. Let's try it. We have bar chart, line plot, scatter plot, histogram, box plot. Okay, first one looks okay. Okay, let's try to see if it can debug. Please always bear in mind, we are using a lightweight local model, so we cannot expect the model to perform extremely well, like ChatGPT 4.0 and so on. Let's try to run again this code. Yeah, we have one chart. Okay, but these buttons seems like a bug. Anyway, I'm going to stop here. So now we have explored the different tools offered by OpenWebUI. So we have the chance to impose or set up some of the system prompt to make hypothetical or simulated new models based on the base model. We use the pre-designed prompts to get results. We try the tools where we can always find here, and we can use each tool by activating it. We have also tried different functions which linked to the model, and we can utilize it while we are in the conversation. So there are so many things that we can explore in the future. I wish you really like this video. If you have any question, feel free to leave a comment. And if you really like my channel, please subscribe. I hope this video is useful for you, and see you next time. Bye bye. Hello everyone, welcome back to my channel again. Today I'm going to show you a very simple project about the Hugging Face model test. Now Hugging Face is a very popular platform where it hosts many models. As you can see here from the Google search page, we can see now there are already more than 1 million different models where we can utilize. And if we go inside, for example, we check one of the model, we can see the model card show you all the descriptions of this model and also the different files regarding this model. And when you want to use this model, you just click use this model, and you're going to see either from the transformer library or from the other channels like LLM. However, different models we may need different packages or different channels to utilize or deploy. And you can also see we have different type of the models like text generation, text classification, text to image. So basically, each model has a very specific task. It's not like what we know about ChatGPT. ChatGPT is utilizing like the GPT for all model to do all types of tasks together. But in Hugging Face, you're going to see different small, large models where it can cater different use cases. If we go to the model, now you can see there are so many different types of the model like multimodal, computer vision, natural language processing, audio, tabular, reinforcement learning, other. Okay. I do encourage you to try them out because Some of these models are very interesting to play with and could further enhance your transformer utilization skill or the skills to complete different tasks, like the task categories we see on the left hand side. Yeah, so it's very convenient to utilize Hugging Face to try out different models. Now, let's check the code to test some of the models. Before we start, we need to install different dependencies that's necessary for our test. Then the first thing that we need to do is to import different models. And in here, the first task, we're going to do text generation. I chose a model which is only 231 megabytes. It's called T5. It's called T5. As you can see here, the model does not give us a very satisfying result. It's actually just take my input text and give me the exact same output. The second model I'm going to use is called DistillBERT. I'm going to use it for sentiment analysis. As you can see, this model analyzed the text of the previous step and it gets the sentiment as negative. If we run this again, it could be positive. So this model is not very stable, but if you run this model, you can see here there are very clear description, or we can say suggestion. You should probably train this model on a downstream task to be able to use it for prediction and inference. This is very important. So this is a very basic model that you need to further fine tune for your specific task. If you use it like this, you will not, or most likely, you are not going to get a very satisfactory result. And then here you can see we are going back to the Q&A model of BERT. But here I only have a very simple logic to see if the previous sentiment is negative or positive. Then I'm going to ask different questions to the model. But here, this is only for demonstration purpose. You can easily identify that the question is not including the context. The pipeline is not very robust because you get the sentiment from the previous answer, but you are not including all the context of the previous answers. This one is just to let you know that you can add this logic in your pipeline, but to make sure that you get the answer you want, you need to consider the context. Without context, this model will do a freestyle answer. As you can see here, the question is what causes a conflict in negative story? What negative story? What negative response? You need to include all the context. Without that, you're going to get a very random result. And this being said, even if you include all the context, using a very simple model, you may still get a very partial or inaccurate result. The next one is text summarizer of BART, summarize the Q&A, and you can see to summarize the previous answer, it gave the result. What will you do for a living? This is totally random. It does not give us a very interesting result. Then the next one, we are going to the translation task. We are asking the model to translate the summary to French. It does give some French output. If you don't speak this language, you may need to double check if the translation is accurate, or you may use other translation tools to double check. There are also some different models to do the translation task that you can try in Hugging Face. The last one, we use a Diablo GPT. It will respond to translated summary. So as we can see here, its response is almost the same as the input string of the previous question. So now we finish a very simple version. In this version, you can see we have different models handling the different stage of the pipeline. But there are several issues that we need to understand. First of all, the limitation of the models. If they are small, they may not give a very robust answer. And in your pipeline, if you do not decipher or include the previous answer correctly or organize the information string effectively, the answers are not very useful. Now let's see another version. In this version, I actually simplified the pipeline. Let's just focus on several things like Q&A, like summarization, and also translation. So the first thing I'm going to use is GPT-2. I'm using this model to generate the text. My question is the future of artificial intelligence. You can see the future of artificial intelligence is in question, particularly with robots on an increasing large scale. Well, it makes some sense, right? This answer is much better than the previous version, like we use other models. And there are no scientific approaches to improving AI. Grammatically, there are some errors here, right? And no real evidence of how robots can improve that. Well, makes sense, right? And it also says IBM's Watson is a sophisticated computer that uses. Okay, we already reached the maximum text window. Okay, so the answer finishes here. Then we use T5 small model to summarize. It says the future of artificial intelligence is in question. Okay, and yeah, it gets some of the words from the previous answer. Summarization is not perfect, but it can be more useful than the previous version. Then we do the question answering. Okay, I ask, what is the text about? It's about the future of artificial intelligence. Okay, then we use this model to translate the text to French. You can see here. Okay, it translated the text. And also we use this model to do the sentiment analysis of it. It says positive. However, I think the summarized text is neutral sentiment, right? However, the model predicted it to be positive, which means that the results could not be very accurate. So as you can see, the two different versions, we use very simple models. We can get different results utilizing different models. If you use larger, more sophisticated models, you can get better result. And I'm using these models because they are CPU friendly. So in Colab, if I do not have the computer resource, I can utilize them to do some tests. This is point number one, why I use small models. Second, you can design a pipeline. You can design a pipeline utilizing different models for a specific task. For example, like the natural language processing, if you use a simple model like transformer model, BERT model, if you fine tune it to do text classification, some very specific task, the result may not be worse than very advanced frontier model. Today I have not yet shown you that, but in the future I'm going to do some videos to check the different models as long as it is well trained and can fit into CPU, which means that the inference speed is not so slow and I can use it in Colab. The last thing I want to share with you is that the design of the pipeline, consideration of the information flow are very important. The second version, of course, is better than the previous version for several reasons, like I choose a different model, and to get a useful result, maybe I do not need a very sophisticated pipeline. I should start with a simpler pipeline. Like the previous one, I use some logic and so on, but in the design, in the writing of the code, I miss some points. So eventually it cannot be a prototype for me to develop to the next stage. The second version can be better to improve because the pipeline is simpler and I can identify the problems easily. And you can see the basic code structure is much simpler, right? So we are using one input to get an output, then the output will be the input of next stage. Make it streamlined so you can see this whole process. I wish you like this video. This is just the first step that I'm going to interact and design different workflow with Hugging Face models. I wish you like it. If you like my video, feel free to share it, give it a like, leave a comment if you have any suggestion or any doubts. Please subscribe if you like my channel, and see you next time. Bye bye. Hello everyone, welcome back to my channel again. Today we are going to test the new Llama 3.2 models with different tools. The tools we are going to use include LLM Studio, Ollama, Grok. So basically we are going to test three use cases. The first is to ask a large language model about concepts and verify the concepts. The second one is to test the coding capability of both models. Then we are going to utilize the agentic workflow both of Crow AI, and also the AutoGen, and see how they can interact with these models. So before we start, I just want to mention to you the models I use, although they are all Llama 3.2 models, they may have different quantization model. A simple way to understand is how these models could be compressed to a smaller size, so you can adapt to different platforms, different machines, local machine in the cloud, and so on. So for LLM Studio, I'm using the LLM Studio community versions of the two models. Then about Ollama, I just do Ollama pool of the third and fourth models you see on the list. You can check their specifications in the official website. The last two are the official models from Meta, released in Hugging Face. I'm not using these two models, but if you are interested, you can check them on the Hugging Face website. And for the Llama 3.2, 1B and 3B models in Grok interface, you can check on their official documentation, see the list of the models and the specifications. As you see here in the Hugging Face, the official release of the Llama 3.2 1B model is in this page. This is a 3B model, and you can see if you want to download it, you need to agree the community license agreement and to do the login. And in Ollama, you can see the Ollama hosts the Llama 3.2 model. You can choose here is 1B model or 3B model. You can see the different specification and descriptions here. Then about the ML Studio, we are back into the Hugging Face. You can see we see LLM Studio community version of Llama 3.2 3B and the LLM Studio community Llama 3.2 1B model. Last but not least, you can see Grok Cloud documentation, models, and you can check all the models hosted in Grok. As you can see, Llama 3.2, all these models are already hosted in Grok platform. And more interestingly, if you want to further test like a 11B model, 90B model, they are all available. So next, you need to make sure LLM Studio is installed in your local machine and all the models are installed for you to start testing these models I mentioned before. For Ollama, you can install Ollama in your local machine and then pull the models so they are ready to be used in inference mode or server mode. And for Grok, you just need to apply for the API and choose the models accordingly. After you install the LLM Studio, downloading the model to be able to load in later stage is very easy. You just choose the search function, input Llama 3.2 and click go. It will show you all the results. Just to be safe at this moment, I chose the LM Studio community versions because you see there are so many versions and in each version you can see the different quantization level. So I choose the LM Studio community version and use the largest model available. Because the model is already very small, I don't think it's very necessary to just compress it to a smaller model. So I use the LM Studio community for the 1B and the 3B, as you can see here and here. So you can also open the browser to see the model card in Hugging Face. As you can see here, the model card are shown in the Hugging Face pages. You can go here, Playground. In here, you can test the different model simultaneously, or you can go here, Local Server, to load the model. In here, in the Playground, you just need to select the models you want to load. I have the 3B, 1B models, Llama 3.2 and just load the model. Then you can see the model is successfully loaded. And here you can see if your local PC resource does not allow you to load the multiple models, it will give you a notice. Loading additional models is temporarily disabled. Unload models to free up system resources. So in my local machine, I cannot do them test them together. So if you can do it, you can use this playground to do it. Then you go to a local server. In the local server, you can load any model you want. For example, if I want to load this model, after loading, you are going to see it is ready. Make sure that you can choose a proper server port to avoid the conflict. And the different settings, for example, how to utilize the inference structure to LM Studio are all listed here. You can check on this part. But since the interaction with LM Studio and Ollama in local environment is relatively more slow, so I just show you this option. If you want to try it, you can try it. So in my later tests, I'm not going to use ML Studio as a server in local interface. And to prepare Ollama and the models in Ollama, first of all, you need to install Ollama in your local environment. Then you can pull a new model from the Llama server. Please pay attention, 3.2 default model is 3B model. So like you see here, the first time when I pulled the 3.2, it actually gave me the 3.2 model. Although here it does not say it, it is actually the 3B model. Then if I specify I want to pull the 1B model, it will pull the 1B model. Then you can see this is the new result. I got a 1B model and the 3.2 latest. And if I pull 3.2 model 3B version again, the name will be changed. So if you pull it with the correct name at first, you will not be confused about the names. After preparing these models, we can utilize different agentic flow to interact with Olama. And to utilize Grok platform to access different model, you need to go to the Grok cloud and prepare your API key. After you prepare your API key, you are going to utilize in your code. I'm going to show you later. So basically, the cloud case, the Grok case is a mostly simplified case because you do not need to manage all the models locally. So the first question is what is large language model? Second one is what is linear regression? The last one is what is loss function in machine learning? Let's try them out. Because my local machine does not allow me to do testing on two models simultaneously, I'm going to do it one by one. So now I'm in the AI chat and you can choose a model here, so the model will be loaded. We are going to ask the questions previously. As you can see here, the model is generating the response. So just to avoid you to read this slow generation of results, I'm going to show all the results all together later together. As you can see here, I have two charts. One, I talk to 3B model. The other, I talk to 1B model. And you see here, this one I show you is from the 3B model. But since now I have not removed the 1B model from the loading pane, so you can see here, whenever I go back to the 3B model chat, it will notify me, reload this model. So let's just check the results. So first one is what is large language model? Large language model is a type of artificial intelligence designed to process and understand human language at a scale that was previously unimaginable. These models are trained on vast amounts of text data, which allows them to learn patterns, relationships, and nuances in language. And you can keep reading, and it also shows some of the model examples. Okay, the Transformer XL, this model I'm not so familiar with, but you can check. In general, it is summarized very well and also show you the bias and fairness, can show bias lead to unfair outcomes, and it also give a notice, okay, that there's a potential job displacement, which most people are worried about. Yeah, looks okay. So what is a linear regression? I'm not going to read every line with you, but I noticed one error is that it showed also a non-linear regression. So when I'm asking about linear regression, it gave me some explanation of non-linear regression. So it actually adds some irrelevant information in the answer. But in general, the other part looks okay. Let's see what is loss function in machine learning. So it said the loss function is a mathematical expression that measures the difference between predicted output and actual output in your model's performance. It serves as a crucial component of training process, guiding the model to minimize the error or discrepancy between the prediction and the true values. It could go deeper, but at this moment, if you want just an immediate impression about loss function, is okay. But of course, loss function you can have more points which you added to the concept to help you know the whole picture of the loss function in different scenario. But for a quick answer, looks okay. And it also shows different loss function. Mean square error, cross entropy, binary cross entropy, looks okay. And there are also some common use of loss function for regression and classification task. Looks good. Challenges: choosing the right one, overfitting, underfitting. And also here, the best practice, regularization, hyperparameter tuning. So for hyperparameter tuning, I'm not quite sure because I think it's quite different from the loss function because it's another part of adjusting the model structure. In the future video, I'm going to show you some of the example how we tune the different parameters of the neural network and to see the different results. Then model evaluation. In addition to loss function, use other model evaluation metrics to get a comprehensive understanding. So it actually said the loss function is part of the evaluation matrix. This is wrong because the loss function is the function where you gauge the error. Okay, let's say it this way: to gauge the error of this model, you want to minimize it. But the loss or the accuracy are the metrics you want to evaluate. So I would say this comment is wrong. So let's take a look at 1B. The results from 1B model is quite out of my expectation. For example, the first question about what is a large language model, it gave me a quick concept, type of artificial intelligence designed for natural language processing and so on. Okay, looks okay. And additional information, training data, a massive amount of text data, application, they have a lot of application, looks very well. And for example, it gave me this code block. This is out of my expectation. I did not ask for the code, but it gave me the code. I have not yet tried the code, but in general, the structure looks okay. So you just load training dataset, input in the model to train the model. And it also gives you the key points to note about the training using of PyTorch. Looks very good. It's like concept and practical part. It can generate such information for you. Then let's see what is linear regression. Okay, give me a very short description, and it actually just use two words to representing the linear regression. Just make, I think it makes the context window shorter, and in general it looks well. And especially here, common application and also the code is quite different from the 3B model. And you can see here is a quick example of the linear regression. It looks okay, but of course we need to run it to see if the results is okay. But in general, this sample array and apply linear regression on this sample array looks okay. Okay, so also some key points to use. And importantly, the model uses OLS to estimate the coefficients. Looks okay. What is loss function in machine learning? Let's see. Measure difference between the outputs. Okay, the same as 3 model. The matrix that indicates how far off the model is from achieving the desired outcome. So again, loss function itself, it is a function, it is not a result. If we're talking about the loss value calculated from the system, of course it can be a matrix to evaluate the model. So I do not like this answer. And minimize the difference, reducing the error, and optimize the performance. Okay, looks good. So there's a MSE, cross-validation accuracy, mean absolute percentage error. I need to check some of the concepts because some of the concepts I don't use very frequently. I also need to check its accuracy later. And here we can see it gave an example about the cross entropy loss for classification problems. So it actually gave a sample data set with class 1, 2, and 3, and they use a cross entropy loss to measure the difference of the outcome, and it will print the loss value. In general, it looks good, but again, you need to run the code to understand. And we can see there are key points to note. Okay, so in general, the quality, the precision of the model about concept generation are still doubtful because it may have some misinterpretation of the concept. But 1B model seems to put the answers more concise and give you actual examples. So this is the first impression I have between these two models. Now let's test the coding capacities of the two models. So first of all, let's see the 1B model. The 1B model, the first prompt is a Python code for snake game. Okay, it just define a function and run this function. Okay, and it also gives some notes about this function. But I mean, the most important part is to run this code and see the results. I'm going to show you later. And this is the results of use YFinance package to get Apple price. I want 1 month price data, but from here I already see that it is not getting 1 month data because there is an important variable is the duration was not set. Then use Python to scrape Wikipedia's SP500 page stock list, and in general it seems okay, but I need to try it to test the code. Then let's take a look at the 3B model results. It is more comprehensive. As you can see, first one is about the snake game. It is well structured. First of all, it defines some of the variables which we are going to use in the game, and then use a class, the snake game, and define different functions. Eventually, we run the game. Okay, and it also gave some detailed instruction how to use this file and so on. And also the YFinance part, it sets this parameter as 1 month, so I assume that it will get the results. And about scraping, it's more or less the same as a 1B model, and without reading all the context, of course you can try on your side. Let's see if all the codes can be run with successful results. As you can see here, I copied the code to my Colab notebook, So I run it in Colab environment. Of course, you can also choose to run it in your local environment. So let's first of all check the 1B model. First, the code is a snake game, and we get this error. Print board is not defined. So basically, we just go to the first few lines. We have an error. Okay. Then about the finance, Y finance package, it actually gets the price data. I think this is a current market value of Apple without giving me the 1 month price data. About the Wikipedia SP500 list, the result is empty. Then we check the 3B model results. First of all is the snake game. It can be run. Actually, in Colab environment, it actually shows me this interface. Whenever I choose the direction, it just prints out the new layout and ask me to choose again. So, but you cannot hit the snake by itself, or when you go to the border, you get an error. So there are many things that could be improved, but at this moment, at least it can be run and you see some results. I would say it is okay. Then we see this Y finance package utilization. We get the 1 month closing price data of Apple. And last task, we test the scraping of the Wikipedia page. It actually gets an error. Non-type object has no attribute find. So the larger model, 3B, actually wins this time by successfully running 2 code blocks. Okay, although one code block is failed, and the 1B model actually gets only one partial result about stock price, and all the other 2 codes failed to perform. And now let's go to the last topic about agentic workflow with Olama and Grok. So we are going to utilize both the AutoGen framework and also the Crew AI framework to do different tasks. Now let's check the results. So on the left hand side, you can see this is Llama 3.2 3B model hosted in Grok. And on the right hand side, I chose the model Llama 3.2 1B hosted in Grok platform. So basically, first of all, we need to install the AutoGen package and the Grok package to utilize both tools. And I'm just go through the most important part. First of all, you need to properly set up the configuration list. Okay, so I just designed this drop-down list to allow you to choose the different models so you can test. And the first agentic workflow example is taken from the AutoGen official website, is a coding task. So basically, the agent's group chat will eventually get a code block generated and execute it to see the results. You can check the example in the official website. So I'm just going to show you the results directly here. So in the interface here, I just choose a model. Like you see here, on the left hand side, I chose the 3B model. On the right hand side, I chose the 1B model. And both work fine to generate the code. Okay, the task is to count the number of prime numbers from 1 to 10,000. Okay, so both of them get the code working. Although you see the variable name on the left hand side is I, right hand side is none. So not much difference. Both did a good job. And execution results, let's see. Both sides 1229, which is the same as the official example in AutoGen website. Looks good. And you can also see a summarization of the chat results. Then we go to another example, is a group chat in AutoGen, a different example. In this example, actually, the group of the agents will perform 2 actions primarily. First, to retrieve the documentation or the context, then analyze the document. So in order to retrieve this document, it actually uses a coder to generate the code to get the information. Okay, so let's see the results. You see the prompt is find a latest paper about GPT-4 on the ArcCV and find its potential application in software. Okay, so we see left hand side is 3B model, right hand side is 1B model. So let's first take a look at the 3B model. Okay, it goes to generate the code, okay, and describe you how to analyze the different application in software and so on. And also the coder tries to code and to And you can see here there are some generation of the code and so on. Then execute the code, you get error and so on. Then it goes on and on, but it seems that there is no correct code generated because you can see the code output, no paper found on GPT-4. So there is a potential issue about the code, and eventually I exceeded the Grok token limitation. So I just stop here. So the different agentic workflow was executed uh, with success. I mean, from the flow point of view, but the result is not so good because we cannot get the paper and the information. So let's take a look at the 1B model on the right hand side. So the same workflow, it first of all let you know that it's a large language model, do not have the ability to process a dynamic links. Okay, then they generate some code, but that code of course cannot be run because it's too simple, and you can see there are some errors. And yeah, eventually it also gets to improve the code, but when we execute the code we got error. Okay, so it's like this, and eventually it said it still comments on the error of the code, but eventually we cannot get satisfactory results. You can see a summary of this code of the agentic flow, and that's it. So both models failed at this task to make this agentic workflow work. Now let's take a look at the official example. So in AutoGen website, the same agentic workflow goes on, and because it was using, I think, a GPT-4 model. Let's check. Yeah, you see, it got GPT-4 models, and eventually the code was generated and executed to get the information, summary of the paper, and eventually they gave the opinion, okay, and terminate the chat. So again, these two models are smaller models than GPT-4, and of course in the agentic workflow, they do not work very well with AutoGen for the cases I just mentioned. Of course, if you implement additional tech, additional tricks with the design of the workflow, you will get better results. So the first agentic example is a very simple one, and we get a result. The second one, when we talk about retrieving information, both models find some difficulty to execute and get eventual correct results. Now let's go back to the local machine. Let's test the agentic workflow with Llama using Llama 3.2 1B model and the 3B models. So as introduced, both models could be pulled from the Llama, and I just use a Crew AI framework to design the workflow. So basically the workflow is very simple. I just have one student agent, the other is a teacher agent. Okay, so student ask teacher questions on 3 levels. As you can see below, here we have 3 level questions. Of course, you do not need to test this much of question numbers. So eventually I change it to 3, 6, and 9 in the 3B model version. Okay, just to simplify the agentic workflow and the limited response length. And as you can see in Crew AI, we need to both define the agents and define the different tasks. Okay, then you are forming this crew group using relevant functions. And let's see how it works out. Okay, so basically using 1B model, we immediately get this error. So in Crew AI, when the different agent calls another agent, it's very important about the name, and it is case sensitive. Sometimes the agentic workflow can figure out which is the eventual correct name and call the correct agent, but this requires you to be very careful about your coding part. You need to implement some flexibility, or you use a better model to achieve better results. Like this one, we use Llama 3.2 1B model in Llama, and we only get errors. Okay, so it cannot find the coworker, and we do not get any result at all. So I stopped the workflow. However, for the 3B model, let's see. Okay, it actually starts to generate the questions to from the student to ask a teacher. I want to understand the basics of statistics and its relevance in everyday life. Okay. Then here, coworker not found. Okay. So it goes back to thinking by itself, the student. And let's see here. We get the answer from the teacher. Statistics is the study of collection, blah, blah, blah. Okay. We'll get the answer. And then back to the student. I now understand the basics of this question. And additional question generated. Explain the main types of statistical measures. The teacher got answers, then replied. So basically, if you see a different color, this is the reply after the thought chain, I say. And you can see we get some results. But later, we see error utilizing tools, two validation errors of asking questions to coworker schema, and we can see some value is missing, and we lost in the chat flow. But when you retry this same workflow with the same model, like this version, you are going to see quite different results. So basically like this one. Okay, we ask questions, get a response, okay, and we can go more rounds. As you can see here, we go to deeper questions, like what type of questions should I ask when trying to understand statistics, okay, and there are some questions generated, right? And then we can see this conversation can go on, but at a certain step we can see the action input about the question, observation, thoughts, the action input, observation that keeps is like the thinking process of one agent got stuck. Okay, and it still tries to ask the other agent, ask a teacher these questions, but it seems that it does not get passed to the teacher agent. And as you can see here, I should also ask contextual questions to ensure I understand the broader concept and so on. So there is no interaction with the other agents. Okay, it's a self-reflection process. And now we can also see some code generated, but we do not get very meaningful discussions between the two. Eventually, we got an error, and I stopped this chat work. So basically, both models can handle a certain number or rounds of conversations in CrewAI, and of course 3B model is better than 1B model because it's bigger and it can handle more complex situations. So we have done the journey of testing some use cases with the new Llama 3.2 1B and 3B models, but before we go to the conclusions, please be careful about the interpretation of the results, because whenever you utilize different models, you need to check the specification. For example, the LLM Studio community version may be different from the Ollama version and may be different from the Grok version. Okay, because the different quantization level, you have a different size of the model, and in a very strict sense there are different models. Okay, they may be based on the same framework, the same original model, base model of meta, but they may be slightly different. Okay, so whenever you interpret the results, please make sure that you understand the backstory of different models. Here I give you a simplified peer comparison review. So let's go one by one. We have done a Q&A on concepts and on specific questions. So both models have shown some results, and the 1B model seems to be more practical, give you some coding suggestion, and the 3B model in general give a more comprehensive, better answer. On specific coding task, of course 3B model performs better than 1B model, and on the agentic workflow, both models from the Grok website work very well on the simple math coding task, the agentic group chat, and about information retrieval, both failed. And on local tests with Ollama and CrewAI, the teacher-student chats have more meaningful conversations in 3B model than 1B model. And if you keep testing, for example, with the CrewAI, to start a new conversation between the student and the teacher, you are going to see different results. So the randomness of the response and the interactions is very interesting for you to explore also in the future. Before we close this episode, this video, let's take a look at the official website of Llama 3.2 published by Meta. I'm just going to mention two things. First of all, in the front page, it said lightweight and multi-model Llama models. Okay, lightweight means that 1B and 3B models are smaller in size, so it can adapt to different devices like our mobile phone, like our laptop, and so on. Regarding multi-model models, of course, you can try in the future and see how these models work. So today we just tested the 1B and 3B models. They are on device, they are small, they are faster, and we can see there are some pros and cons about shrinking the model size. Especially you can see on different tasks the performance can vary. Then you can also check on the official website about the different benchmark comparison. For example, this one is the vision instruction tuned benchmark. Okay, it's about multi-modality models, and about the lightweight instruction tuned benchmark about our Llama 3.2 1B and 3B models. We can see that it cannot surpass or go over some benchmarks of the previous models on all benchmarks. So let me say this. In my opinion, different models may be more suitable for different use cases, but you need to test to understand, and on your specific use case, you need to design a better structure to utilize these models. If you only rely on one model to perform all tasks, for example, less like these on-device smaller models, it may not get good results. But I'm going to check in the future if there are some more creative design. For example, in the on-device situation, it can perform very specifically on a single task with very high performance score. I'm going to share with you, and I think there are potentials about the smaller models, but the generalization or the ability to handle a more broader range of tasks is not as good as big models. Anyway, let's keep on exploring and see what the large language model community is going to bring us in the next time. So I wish you like this video and wish you have a good day. If you have any question, feel free to leave a comment. If you like my video, please subscribe to my channel and see you next time. Bye bye. Hello everyone, welcome back to my channel again. Today we are going to talk about cloud. It is very similar to ChatGPT, but it has some very unique characteristics I would like to explore with you. So in this video, you are going to get some useful tips. These tips will mainly focus on the prompts and how we use this chatbot. Just a brief intro. Cloud is developed by Anthropic. To try it, you just need to click Try Cloud in their main page and log in. And then we're going to focus on two objectives. One is to use step-by-step unstructured prompts to get what we want. The other example is to use, and there are also some examples focused on structured prompts, which we may self-design a structured prompt or ask another large language model to give us a structured prompt and feed into cloud. So now let's dive into the step-by-step prompt scenarios. Since I'm using the free tier plan, at this moment I do not have additional quota for my tokens, so I'm just going to show you the past chat records and to show you the cases. The first one is interactive transformer visualization app. At first, I just asked the model to design a dynamic app to show how transformer works, be as detailed as possible, be engaging, elegant UI. So I do not have a very structured prompt, and the model starts to write the code. I see this artifact showing on the right hand side. You can see the code part was the whole coding process displayed on the right hand side. After the model finishes writing all the code, you can preview it. So you can see here, it actually shows you some of the most important parts, important steps of transformer model. Of course, sometimes when you run it, it may not meeting your expectation. You can always improve. But at this stage, you can try to run it. You can see it is dynamic and shows you a general idea of transformer. From a zero-shot point of view, now we already have something that we can work on. As you can see on the left-hand side, we have some description about the key features, key aspects of the app designed by this model. And in general, it looks good as a starting point. As you can see here, if we go to the final step, our output is just a reverse sequence of the input stream. So this is not as we expected. However, we can ask it to improve this app. Let's say show also matrix calculation simulation. Then it correctly displayed that the animation will reach the self-attention step and will display Q, key, V matrices and attentions and output matrices. Now let's take a look at this one. Okay, so if we try it, we can see here it is not working. There is error. So in this case, usually you can click here to ask the model to debug it, or you can just on the left hand side ask it to redo and write your concerns or the issues you meet. So it will go on again. Usually, if you are in the free tier plan, it is very likely that you need to ask several times to get a very useful result. As you can see, until here, I said debug and improve, nothing happens. Until here, after several rounds of chat, now we can have something including both the input string, transformer process, and also the matrices, the Q, V, K, attention, and output matrices. Of course, it's not 100% accurate, but at least now we have something displayed here. So let's see. I find it too simplified. I want it to highlight the stepwise calculation results. Let's see. Actually, here you can see in each step, it actually separates the different matrices inside of each step. So whenever you see it dynamically here, you're going to see each step involves different matrices. This is improvement, but as you can see, it is still far away from how transformer model actually works because it's only showing partial information. Eventually, I hit the limit, so I did not go on with the improvement. But at this point, you have two choices. You can debug this code by yourself, improve this code by yourself, and run it in environment about the React application. Or if you are in paid plan, you can keep asking questions to improve the app. Or as an alternative, you can just copy this code and ask in another model to improve. The next example I'm going to show you is also the step-by-step prompt. So in this chart, I asked it to provide me dynamic chart showing macro indices for Eurozone for the last available data. And it gave me, first of all, an empty chart, but it mentioned some of the information here, but we do not see the data. So I say, I see nothing, and ask it to improve. Actually, at this step, it shows me some figures about yearly GDP, inflation, and unemployment of the Eurozone. I suppose this information comes from its training data because I do not see any citations here or available links. Of course, you can add such requirements in your prompt to get a fully cited data. Then I say I need a bar chart, line chart type of thing. It's a very general prompt. The first attempt, we got error. Then I said nothing showed. First of all, it redo the table or tabular information to display to me how these data evolve in the past years. I think this is an improvement because it comes back to check the data and display in a structured way. So I ask it to show me the bar chart. Let's see. This is very interesting because this is not a dynamic bar chart. If you use Python, you know Plotly, you know different packages to show the data dynamically, either bar chart or scatter plot. But this one was out of my expectation. So the model actually is showing the bar charts in a very different way. It is not showing the results in an elegant display, but it is use the ASCII code. It's just showing you some black boxes and simulate a bar chart. As you can see here, we have a scale that each black box equals 2 units for GDP, 1 unit for inflation and unemployment. Now, let's go to another example. In this example, I'm evaluating the question and answering responses of a different large language model. If you saw my previous video, you know I did some tests about Notebook LM, a new product created by Google, and it can help you summarize and retrieve information from the information you provided. I asked Cloud to evaluate each of the responses. As you can see here, some of the information are pasted here, some of them are txt file. So no matter which is the format, you can feed to the prompt altogether. Then I said I use as many as measurements possible on judging below QA quality, show results in a table chart. The first attempt, as you can see here, the artifact failed to load, which means it's not working. Then we try to improve, and you can see this bar chart. Okay, from a UI point of view, it is better than the previous chart that I showed you, because in this bar chart, you can see it is dynamic. When you hover the pointer above each data, you're going to see annotations about the name and average score. Okay, in general, it looks good. I also asked it to provide a valuation grid, which means that I wanted to see details of the evaluation, not just the average one. But unfortunately, the model does not provide me evaluation grid. Then I ask it to actually show me the table. You can see here, there is a table of the evaluation of each QA document. And you can see it evaluated the consistency, clarity, completeness, accuracy, simplicity, and the average score. Then I ask it to show me a dynamic table. No, it cannot. So in this case, we actually feed into the prompt with multiple information. It can help us to evaluate, to summarize, and provide us dynamic display. But please pay attention, at least in the free tier model, it cannot always successfully show you the data visualization in the artifact. Now let's take a look at some examples of structured prompt. First of all, I'm going to use step-by-step prompt to show you the first results. Then we take a look at the structured prompt case. So my use case is to design a Russian cubic game and demo it. So it actually annotates the game in Russian also, and the artifact can be run. Let's see, you can just play the game. You see, in general, it looks good. Let's see if it can cancel. Yeah, it seems to be working. And we can also see the score here. As you can see on the left hand side, it also describes how this game is designed. Then I ask it to improve the UI. Let's see. Okay, after the improvement, you can see the UI is much user-friendly because you can see each box now is not so rigid. It has some curves in the points. Let's try. Yeah, it is working. Okay, it is working. But as you can see, if I long press the down button, it does not go faster. So there could be many different details that you can improve. And I say further improve and allow the speed up function. And let's see. So in this case, let's see if we can speed up. No, we cannot speed up. Let's try it again. Okay, we can turn, we can drop, but we cannot speed up. We can move, no problem. Well, whenever I click drop, the shape just stayed in the middle. This is kind of a creative design of the game. Let's take a look. Because it's not meeting my expectation, I ask it to redo. As you can see here, the UI seems to be going back. Okay, not so good. And let's see if it works. No, nothing works because you do not see the shapes here. Whenever I refresh, you can see there is a prediction of next piece, but I do not see the shape. So it describes the detail of how it designed the game, but it does not work. Okay, in this case, you see I did the step-by-step prompt. We have some nicely designed game and also some failed cases. But one thing I want to mention to you is that there are some advantages to use a simpler step-by-step prompt because the process brings you more clarity. You can manipulate some incremental changes to your results getting from the large language model. Now, let's take a look at the structured prompt. So basically, I go to ChatGPT, I say, design a comprehensive prompt to ask Cloud to design a dynamic React game of Russian cubic. So it actually gave a very detailed description, like game overview, key features, and it is very comprehensive. And especially, it mentioned the game logic, which I think for the designing of the game, before we go into the graphics, game logic is relevantly more important. So let's take a look at the result from Cloud. As you can see here, this is a very long prompt. It starts to design the game. Let's see. The reason that in this case we do not see some artifacts is because now it offers a more structured game design. So it's not like one React file will be run successfully because it may have some interconnections with other files. It's like when you write a Python program. Okay, you have the main.py, it will interact with others. It's the same logic behind. As you can see, there is a code written, but we do not see preview. As I said, I think the main issue is that now we have more comprehensive structure, so the model itself cannot handle the artifact successfully. Then we can see here are different files, like this one is about the shapes and functions. This is an independent file. Of course, you cannot get any preview. You have a gain helper function and different file. Okay, I did not try it in my local environment. I just want to show you first, if you have a structured prompt, actually the result will be also structured, but it is not so easy to manipulate because now you can see you have so many different building blocks. You need to test and try each part, not necessarily in the cloud environment. You may need another environment to test it. So I mentioned some of the errors it shows, and it kind of go to the debug process, and there are some updated code. But again, here preview, we see nothing. Then I asked, can you simplify and show me a demo right away? It did, and as you can see here, this is the demo it gave me. I can only add random pieces, but there's no game playing here. So I'm going to the next prompt. I describe the issue and see if it can solve it. As you can see, I can speed up. I can see the shapes dropping down, but I only see one shape. It's a 1 cubic at a time. So at this moment, I reached the chat limit. I get this demo, this simplified demo, although it does not have a very elegant UI, but it seems to be working. And I also have a structured result, like the previous chat. We can see different components of the application. We may try it in local environment or in another environment. Now let's check another case. In this case, I'm asking ChatGPT to give me a structured prompt to ask a cloud to produce the Apple stock analysis report. So the prompt is structured as company overview, financial performance, stock performance, valuation, growth, prospects, recommendations. In general, it looks good. It also said make sure to cite relevant data and provide clear and concise insights in each section. Looks good. And let's go to see how the model responds. After the prompt, the first gave me this artifact about the report. Remember, this artifact is shown on the right hand side. It did not produce the report on the left hand side as part of the plain text response. As you can see, the format is very good. As you can see, some of the titles are in bold format, and in general it is structured well, but please pay attention. Most of the numbers are hypothetical, which means that these are all made up numbers. But some of the recent developments, it looks okay. I doubt they are the most recent. As you can see here, it said my knowledge cutoff was April 2024. Then we can also take a look at the stock performance. Since they are all hypothetical, we just have a general idea about the report layout, but these data cannot be utilized. Also the valuation, it is good. It shows the P ratio, forward PE, and so on. Growth aspect, growth prospect, generally it looks good, and also risk and challenges, and eventually a recommendation. It is a bit close to the real scenario when the analyst analyzes a stock. But since some of the information are not reliable, we cannot use it. Then I said, can you cite real-time sources and make numericals in graphs? The first response, the model actually denied me for the two requests. First of all, it said I need to find the real-time numbers by myself from different sources. Then about the visual, I needed to do it by myself using Excel, Google Sheets, or so on. And it gave me some recommendations which data could be potentially visualized using different data visualization. However, I said only make the data you gave to visuals. Right, so I just want to see how it transfers the data to visualization. It actually used the artifact to show some of the data. It looks good, but some artifacts does not work, like this one is YTD stock performance comparison. About valuation, there is a table display, looks good. And it also made some additional comments, like some of the charts it did not provide. It provided me some ideas how to create them. So in general, you can see regarding the structured prompt, like generating reports and so on, the model will respond with a very organized information format, like this one is a report format. And you can also keep on asking to improve some of the parts. But at this moment, it cannot just improve the existing report. For example, ask for visuals. It cannot just add me another graph on the right hand side of the data. In this test, we can see structured prompt can in fact ask the model to generate more structured layout, but for the details, we still need to be prudent because like the data citation, like the visualization, like your additional requirements. Let's conclude this video. So I have shown you two different types of interaction with cloud model. One is with a step-by-step prompt, the other is with structured prompt. As you can see, in the step-by-step prompt case, you can do more detailed manipulation about the interaction with the model, get step-by-step results, and you can also see clearly the incremental results and improve your understanding of the process. We have tried the case to visualize transformer model mechanism to gather and visualize economic data and to evaluate Q&A transcript from other models. In the structured prompt case, usually we can have more comprehensive output, which will require us more time to investigate each component, to review or debug, either in the programming case or in the report generation case. We have tried two cases. One is to build a Russian cubic game. The other is to generate a stock analysis report. So I wish this video is useful for you. If you like my video, feel free to give it a like, leave a comment. If you like my channel, please subscribe and see you next time. Bye bye. Welcome to my channel again. Today I'm going to show you the pros and cons of using ChatGPT, which is my personal experience utilizing ChatGPT for coding, for data analysis, and also for the daily Q&A. On the pro side, first of all, it can be the inspiration and idea generation source. It can serve to do the brainstorming, help to structure and generate ideas. Then it now can interact with external resources, like it can link to the search engine and to enhance the information retrieval. Then it now can provide more options of customization and also the query mechanism. First of all, it can let you customize GPT to limit the scope of the GPT to feed different reference documents to make it more task specific. And by default, the fine-tuning process of the output can always include the prompt engineering. I think now is a very important uh, topic that we can explore. About the cons, I really would suggest you to pay attention to. First of all, there is a usage limit. Of course, when you use the ChatGPT 4 model, at a certain point, it will tell you, okay, now you reach the limit. You need to downgrade to 3.5 model and wait again for the limit to be restored. So this can be sometimes very inconvenient because when you reach to a certain step of the project, of the Q&A sequence, suddenly you lose the capability of GPT-4, you need to use 3.5. It may deviate from your original designed trajectory of Q&A. There is also a hidden computational limits. I really would invite you to pay attention to this because as sometimes when you ask a very complicated question or you would expect more robust output, more comprehensive output, when you hit the computational limits, the answers will be very simple, very generic, and it seems like a protective mechanism of the GPT. So this is just my understanding. Uh, then, based on all these kind of limits, I think the recursive improvement challenge is also a result of different limits, like usage limits and also hidden computational limits. Because uh, eventually, when you repeatedly ask a question to improve a part of HTML code, actually sometimes GPT does not improve at all because its knowledge is limited at some point. For example, when I want to modify a specific line of the code, I want to, for example, improve the aestheticity, the display of the HTML. It cannot do it. So in the future, if I have the chance to show you some demos, it will help you understand my point. But for now, really pay attention to this. Sometimes we'll ask a question again and again. It may not get better answers. And furthermore, outdated information, it actually relies on the training data a lot. So if the training data is outdated, you cannot expect the large language model to get updated information, but you can improve the response from the GPT utilizing the updated data to feed in the data sets and so on to actually get better results. Okay, but still be careful about the information generated from the large language model, especially when you ask the question without feeding additional information. Uh, there is also additional personalized GPT limitations. For example, when you utilize a GPT, like one of the GPT I created, to ask the GPT to focus on the GDPR, General Data Protection Regulation in European Union, ask it to focus on that law and generate answers based on that law. I uploaded to my GPT. I created this GPT and also write a objective statement. Um, Sometimes it will refer to the document I uploaded. Sometimes it will ignore it and it give me the generic response directly. So I really recommend you to pay attention to this personalized GPT limitation because the answers are not always linked to your document. When you see that sign of a query your uploaded documents, that is the time when you have the results referencing the documents you uploaded. And at that moment, I think you can have a GPT that really uh, utilizing the material that you uploaded. Apart from that, really pay attention. Sometimes it only gets to its own training data and give you the prediction of the words as it likes. Finally, I would like to give you some recommendations. First of all, if you are not familiarized with different strategies of improving the output of the large language model, use multiple online offline models to improve the solution to a problem. For example, when I did some complicated coding, I would do the process like below. First of all, I ask ChatGPT, then I go to the Hugging Chat, and then I can also ask the Llama 2 uh, online version, and now we can even use Grok. Okay, so by interchanging to different models, you can improve the answer because their training data may be different, so you can get more insight. And sometimes, hopefully, you can fix complicated bugs. But that is really a rare case. Uh, Apart from this, you can try the RAG strategy. I think now it's very popular because like LangChain is designed for the RAG strategy. It will improve the prompt and also the information retrieval mechanism. I call it a query mechanism here, maybe not a very scientific term, but eventually the RAG mechanism is the main goal is to get a more robust response output. So in the next videos, I think I'm going to explore, especially on the RAG part, to share with you some of the journey I just made. But like the right hand side, this is the project I'm going to show you in the upcoming videos. Actually, I want the large language model to intake the document description of LangChain and also the local LM Studio code format to help me guide me through the creation of LangChain strategy, which is to implement a RAG strategy on local environment. So far, I can tell you, based on all these uh, cons, okay, the defects of the GPT and also the other language models, uh, all the models actually direct me to another solution. It's similar to the land chain, but it guides me through uh, a journey to actually utilize the local data and the document I have and to improve my prompt and feed it to the local large language model and get a response. So just to keep it quick, I show you this is basically the debug report. It actually shows you the steps of uh, the, the quasi land chain workflow. Uh, it's not land chain. It's how the large language model guide me to a workflow similar to land chain. Basically, the code, the the final code, first of all, utilize the data frame that I already have in place, and also the PDF have in place, and stored them into documents. Okay. Uh, Basically, the first saved documents is about the legislation. The second one is about the dataset. Okay, the dataset actually transformed to the TXT format for easy processing. And we got the embedding store. The embeddings are stored based on the information we provide. Okay, and we feed the query to a large language model. So here you see the query is only the query I designed to prompt to the system. The actual query to the system, to a large language model, is more complicated like this because it also retrieves from the uh, two embedding stored in the system uh, to get the most relevant information from the law and from the dataset I provide to the query, feed to the large language model, and get the below response. Uh, to be honest, when I get this response just 30 minutes ago, it is actually improved version from my previous results. So basically, next time when I share this project in detail with you, I'm going to share also different tests I had and some mistakes I made. But this eventual response I get is, I think I would grade it as 6 to 7 points out of 10 because first of all, it is not a very robust RAG mechanism I would expect. Second of all, this code structure and also the embeddings I created are not so robust. I'm going to share with you some of the defects of the project and also this result. You can feel free to replicate it and to try it. Okay, so basically today, just a quick wrap up. Whenever you use large language model for coding for different tasks, always pay attention to its downside. And now we have different models coming out like every week or even every day. Always pay attention to check it if it is suitable for your use case and try different strategy to improve the output to get your desired result. Just one last thing I want to remind you is that this HTML file you see on the left hand side is actually the result of the of this code here is called GPT summary. Here Actually, this summary is generated by ChatGPT. Uh, I mean, for this task, it's quite easy. I just ask ChatGPT to make my ideas, the information I want to share with you, into a nice out uh, nice displayed format in HTML. Actually, it did a good job. I think you can also try this. Okay, if you do not want to use PPT, if you want to use PPT or the Google Slides, is another story. Okay, so I wish you like the information I share with you, and I wish you enjoy utilizing large language model. And feel free to make any comment, discuss anything with me. If you like the video, give a thumb up and subscribe. Looking forward to share with you another project in the future. And thank you. Bye bye. Back to my channel again. Today I'm going to show you one of the example of data analysis, which I did some time ago about analyzing the Melbourne housing market data set. This data set is available in Kaggle. I chose this data set because it was available, directly available, and it is very useful for us either in academic research, data analysis training, or in applying to a real world scenario where you want to determine if the housing price is overpriced or underpriced. So I think this data set is very interesting. So in this video, I'm going to show you the comparison between the GPT-4o and my own project analysis. So on the left-hand side, I ask the ChatGPT to process this dataset, and on the right-hand side, I'm going to show you what I did. So basically, let's first look at the ChatGPT. First of all, I ask it to analyze this dataset by providing this URL. It cannot directly solve this URL, so it asked me to upload this CSV. Okay, so I uploaded this CSV. It started by showing the head of the dataset and so on. Okay, it starts to process the data, and I did not define the exact models that I wanted to uh, examine to run. So it actually thinking. It started thinking about which model is the best model to start the supervised learning process. Uh, Eventually, after checking the data set and so on, it started to suggest the three models: linear regression, decision tree, and random forest. If you are not familiarized with all these models, I suggest you to check the information of each model to make sure that you understand how it works. Okay, these are the very popular supervised learning models. So let's see how it does. I really like that the GPT tries to put all the models in a bundle, and uh, it uses a for loop to actually try the different models. It's quite neat, this code structure. Uh, my project, when I tried to run different models, I did not have such neat coding structure. I actually write for each supervised learning strategy. I actually write independent code in the R environment. So let's see how it goes. So basically, GPT starts to train these models and found that one of the model took too much time, so it actually stopped. So tried a simplified version, and eventually it manages to train two models, linear regression and decision tree. So this means that if you give ChatGPT a very open, very wide question, it will, of course, try to exhaust some of the possibilities to reach a comprehensive comprehensive results. But eventually, if it cannot give immediate results, or the process actually takes too much of the compute, it will reduce the complexity and give you an intermediary or simpler version. So it starts to, because in my prompt I asked it to analyze the overfitting issue. It started to plot and so on. And you see the connection was interrupted. So I really don't know why there was an interruption of the connection, because my internet is always connected. However, let's see, it tried again. But there is still technical issue. So basically, by showing the plot, I do not think it's a very daunting task, very difficult task, but GPT cannot do it. So later, I still do not see any graph. However, it gave me some conclusion. I think just like any product, internet product, they do not want the user to wait too long. Otherwise, it will be a very, very inconvenient way to lose the user. So just to briefly show you, I don't want to go to the very detail of each line of code and the result, but I can tell you this is it does not consider the complexity of the dataset. It did not show the steps of handling missing value. If you need to scale the variables, if you need to take a log value or not, and um, the, for me, this is a very rudimentary and a very basic form of analysis. However, if you are interested, you can try to focus on only one model and see if that one model can be better handled by GPT. Let's look at the right-hand side, my project presentation. So basically, I did both supervised learning and unsupervised learning techniques to analyze this data set. Today, I'm going to focus only on the supervised learning part because I already got some response from GPT. I just want to show you that if you are going to analyze a very complicated data set, I mean, this is not very complicated, but in a sense that GPT find it complicated to implement different learning algorithms. I really suggest you to really get your hand dirty and try to solve the problem yourself. But of course, if you need some coding assistance, you need to clarify some of the concepts, you can use GPT. But remember, always interpret the result from GPT with great caution. So, first of all, I tried to use the most simple one of linear regression, but it also incorporated the feature engineering and the AIC step to find the best models, just to shrink down the independent variable size or the feature numbers. So basically, first of all, we need to have a clear idea what are the variables, categorical variables and numerical variables. So then, in the analysis, I would suggest you to always have a histogram to see all the variables. For example, even if you directly go to see the price variable, it will be very skewed and have a very concentrated in a specific range. So in that case, you will notice that it is not a very good sign. So you need to have a strategy to actually do the feature engineering, actually to find a better variable to explain the value of the house. So I'm going to show you later. Okay, so here, like you see here, if I take a log value of the price per building area, so the value will be more how can I say, closer to the normal distribution. it will not just concentrated in a very specific range, and it will give you more, how can I say, a distributed sense. Uh, at this moment, I do not go to very technical terms. I just want you to understand. For example, if in a daily basis, I want to understand the situation, I try to use some terms that I understand better. But if you are going to write a paper, if you are going to discuss in some academic situation, I really recommend you to make sure that all the wordings, all the terms are very statistical and really about the essence of the statistical concepts. So here I just try to use some plain language to explain to you. So basically, all the variables, like I said, you try to examine its property and to decide if you like. I do not use a price directly. I use price per building area because I think it makes more sense, and because the distribution was not um, very dispersed, so I decided to take a log value to make sure that the scale does not impact distribution largely. Uh, then about the other variables, of course, when I actually do the analysis, all of the variables are scaled. So if you are handling this data set, of course, you need to ask some questions. So if you already have some domain knowledge about the housing market, I think you should make some assumptions. You should understand that, for example, like I understand, the property price change over time. So if the data set contains one housing price at the beginning of the year, the other one at the end of the year, this information actually can change drastically. And if I'm only analyzing it using the simple linear regression, of course I'm ignoring this factor, so my result will be biased. And the factors that influence the price may not be easily exhausted, which means that there may be more than the factors that's shown in this dataset. So you need to be prepared that the regression result may not be so accurate. And of course, the factors that influence the price, for example, subjectively, based on the agent and seller and the buyer's judgment and so on, these are many human factors that could impact your analysis. And based on is like a rule of thumb. If you are going to implement the supervised learning algorithm, or even unsupervised learning algorithms, it is suggested that you scale the data. Do not let the scale of the data to impact your analysis. And also pay attention to the dummy variable, because in one of my analysis, in the following page, you are going to see that if the dummy variable is too many, it actually creates more complexity to your interpretation of the models. And always pay attention to the outliers. Outliers may be business opportunity, maybe a bargain, but most of the time it will just make your model derail, just show you more, make your model more impacted by the outliers. So about the methodology and so on, I'm going to go quickly. Especially there is the AIC process. The AIC process is actually optimization process to help you to choose the best and most significant independent variable. So linear regression assumptions, they are very intuitive. If you're interested, you can check it. I'm going to go over. So here, I'm going to show you the models. So basically, if you are going to ask GPT to do all these complicated matrix, I doubt it, because you see, I have different strategies to handle the feature engineering um, design to manually select the features or use AIC procedure, and I can also subjectively implement the outlier treatment methodology. For example, like the first two columns, you can see that I actually set value threshold to actually eliminate some of the outliers. So basically, here I'm trying in different scenarios to see which one is the best situation to do the linear regression. About the selection of the variables, because we also have the choice of a distance or cluster, so there are also different choice. For example, if you calculate the distance of each house from the center, you're going to get an additional variable. It's called distance. Or if you already use a clustering, k-means clustering, to separate these housing these house regions, you are going to get another dummy variable. It's a subjective choice. Okay, you can try. Um, the reason that you introduce additional dummy variable is just to make sure that you understand the distinction between the different regions or different dummy variable, and to actually have a better understanding if your clustering really makes sense. For example, if we are separating in the Melbourne region into 4 regions, sometimes it doesn't make sense because each block has different characteristic, also a different price range. As you can see here, traditionally we use adjusted R square as um, the the fit, okay, to see if the model is fitting well to the data. So by this sense, 55% of the accuracy on the stepwise regression to use the AIC procedure to choose the best variable. And also, I took a log transformation of the price per building area. So here, I just want to say either you build the models step by step or you interact with the GPT and so on. Always make sure that eventually you are going to compare all the metrics of the algorithms and to have a better idea to see the trade-off. Because uh, here you see that we have many dummy variables the stepwise regression, best of our combo log this model. Um, so when you interpret such a complicated model in business scenario, it's very hard. So you need to have a balance. So if you choose, for example, the second column, the distance, and a simpler model, it's easier to interpret. Okay, you can have more direct interpretation. You do not need to say, okay, now we have this house in a specific block, and the price is blah blah blah. Okay, when you are going to describe the general situation of the whole region, a simpler model will give you more flexibility. But if you have a more complicated model, you are going to be more accurate, and of course you need to know which is the reason that gives it such better enhanced precision. For me here, I think the main reason is that we introduced many dummy variable about the different small regions of the city. So there is also always a trade-off. So I really doubt that GPT can grasp such details when you are going to implement different models. So use GPT with caution. Here you can pause to check. These are more detailed descriptions and also the model itself, which variables were in the regression. And always take one final look back to the model itself, the best model. So eventually, if you still find many of the assumptions of the linear regression was validated, the model itself may not be the best. But from the beginning to the end, you know how to handle your data, you know which choice you made to choose the independent variable, the features, and of course, you know exactly which model for which reason is the best, and when necessary, how you make a trade-off in a real scenario when you implement these algorithms. So these are the key findings through my analysis. So I will not repeat it. You can check it. It's not comprehensive, but it can give you some idea that always own your data, own your analysis procedure. Do not 100% rely on a large language model. It can help you code, it can help you to organize the data, or even help you improve the data handling process. But always remember to use it carefully. Uh, that's all for today. I wish you like this video. So basically, this video just give you some comparison between the new GPT model about data analysis with human lead data analysis results. It may still not be very conclusive and comprehensive. I really suggest you to try for yourself, and remember that tools are tools. Use it carefully, and we may improve ourselves better and faster. If you have any question, any doubt, any video that you want to see in the future, feel free to let me know. And see you next time. Bye bye. Come back to my channel. Just after checking the GPT announcement video, I feel that it would be useful to share some of my comments for your reference. So basically, the first question I would ask myself is that how do I feel about this upgrade of the product ChatGPT? The GPT 4.0, I already tried this model. I do not find it very impressive because what it brings to me does not change much, especially some of the functionality will be introduced next week or in later days. At this moment, I do not see that it has superior speed upgrade or it has a very huge gap between the other models like in Hugging Face. As if you check the Hugging Face, the different people who work in Hugging Face, they post the model evaluation, multiple metrics you can check. It's not very evident that GPT 4.0 is really a very big breakthrough. So then, talking about different GPTs or two phones, both has GPT 4.0s talk with each other, is similar to agents who talk with each other. We know that with open source community resources, we can now create agents locally, and this functionality just brings that talk to voice and make sure that each function call or the interaction between the agents are more smooth. So I also do not see much improvement compared with the open source resources that we can have. The problem is that if you want to make the talking agents to make the text to voice, You need to integrate more tools to your pipeline, to your workflow, and of course, like line chain and different tools can help you to realize that functionality. Uh, about like this example of sarcasm with GPT-4o, for me it is still a problem of agents. So the agents could have personality, have some specialty to do something. We can design it, and especially with the RAG, and also like the tools like a line chain, different framework interchangeably work with each other. The agents or the workflows can work much better than before, not like a random walk in the large language model. So now they can be more focused, they can have personality, they can solve a very specific task, a very nuanced task, um, and more specifically, you see the live demo are all the simple examples. If you go to chat with this GPT-4o, like what we did before, ChatGPT, please give me a joke, or be sarcastic and give me a response to a certain chunk of text, it can do that. But if you compare only this text generation to Grok, or making the ChatGPT GPUs compared with LPU, you're going to realize that ChatGPT has reached a certain limits of the innovation. So we need to keep an eye on the new products and new improvements in the open source community in the next weeks. From a product point of view, I mean, the display of dog meets GPT-4o is funny, interesting, and some people would think it is a kind of interaction. This kind of interaction with AI will make your life with more color, or make your life more joyful. But from a point of view, it is not so useful. And the real-time video to voice, um, I I can only see that they have a much more computer upgrade uh, for the past few months, and they can now process the video faster, because videos are piles of image recognition is nothing new, and also the image to text and to voice pipeline is already a very mature pipeline, so there's nothing new here for me. It's interesting but not new. Then about the real-time translation, Google Translate some time ago already achieved that. The problem is about the translation quality. Now there are many AI tools to enhance such functionality to make sure that the live translation could work more smoothly. Um, and I already tried some of the translation with GPT-4o. To be honest, its quality to from English to, for example, Italian, it's the quality is still medium. It does not change drastically from the previous version, like ChatGPT 4. So my final point is that as we have this more potent, more able tool in our hands, like GPT-4, GPT-4o, we still need to focus on the development of open source community, because in the end, the free open source resources that we can utilize, implement in local environment, will prove to be more valuable if you consider different variables. Like if you consider privacy is paramount, if you have many domain uh, knowledge set, domain data sets that you want to work on, they should be more useful than the large language models in the cloud, because I also see some opinions which says that the large language models in the cloud or trained by others serve for uh, the trainer's objective is not for everyone, because I totally agree that user case is in the hands of the users. So I would like to see the option that the users are empowered to solve their user case using the local large language model solutions or implementations. So I really encourage you to keep an eye on the development of the open source community in response to the GPT for all new functionalities. That's all for today. This new announcement from ChatGPT, OpenAI is quite interesting. So I just give you some of my thoughts, and I wish you like it. And see you next time. Bye bye. Hello everyone, welcome back to my channel again. Today we are going to do some tests about the two transformer structure models. One is called BERT, the other is GPT-2. On my right hand side, now I'm going to run the code and prepare the interface. So later we are going to try it out. I'm going to run now. On the left hand side, we can quickly browse the model information. In Wikipedia, like GPT-2, you can see that it is developed by OpenAI, and it is second in the foundational series of GPT models. The later ones are GPT-3 and GPT-4, now GPT-4o and GPT-4o1. Okay, we're going to test the GPT-4o1 in the later series. Okay, so in this model, I mean, if we really want to dig up and discuss all the details, there are a lot of things. Okay, it actually involves a lot of design of the model and how it is trained and so on. Okay, then there is another model called BERT. BERT model is developed by Google in 2018. It is a very famous transformer model, and for most of the courses in university, now it is a master learn topic. Okay, it is the official name is a bidirectional encoder representation from transformers. Okay, and it is trained on the mask token prediction and next sentence prediction. So basically, either BERT, GPT-2, GPT-3, in my opinion, they have a different design, or progressively they have some improvements on specific task. So whenever you approach a model, it's better that you understand what it is meant to do. Okay, so it is designed for specific task or generative generation of text, or specifically on some task. For example, now we can also see some large language model hosted in Hugging Face, and we can see actually there are some models you see specific on the coding task, fine-tuned for different purpose and so on. So whatever model that is, we need to understand what it's designed for and the basic structure. Okay, if you want to review in detail, it takes a lot of time. But if you only want to use it, it's better to understand its purpose and its limitations and pros and cons. Okay, so before now the code has some problem, I'm going to rerun it. Before that, let's quickly take a look at the models we are going to introduce today. So basically, we have GPT-2, GPT-3, GPT-J, and BERT. Okay, I just put them all here for some comparison. Okay, the larger the model, the more the parameters you are going to see involved inside of this model. And as you can see in my tutorial today, I'm going to show you the GPT-2 and BERT. The reason is that in Colab environment, I can load these models easily. I can even interact with some user interface and to try it out. But for GPT-3, it is not, first of all, the Colab free tier does not allow to load this model. Okay, it is very big. Second of all, we do not have a direct source to get this model. But for GPT-J, I already tried, and Colab already crashed several times. But anyway, if you have a larger quota of the computation resource, you can try it. Okay, I also leave it here. So I'm going to rerun it and let's test it. So first of all, let's check the BERT question plus context simple version. So as you can see, this code is quite simple, right? We first of all import the necessary dependencies, and in Colab, I think Torch and Transformer are already installed. The reason you saw the previous error is because I did not install Gladio. Okay, Gladio is not a default package in Colab environment. Anyway, here you can see we import different packages and tools, and we specify which is the model we want to test, okay, and also the tokenizer that we want to use, okay. And you can see here, the reason you see the title is question plus context simple is that this model actually is suitable for the task where you specify a question and also the context. So the model will put your question into this workflow of the model, and to query is like querying the context. And the input to the model is actually to tokenize both the question and the context. So tokenize is to break down the sentence to word. If you consider word as a token, it is breaking the sentence to the word level. Okay, but the tokenizer may have different variations. Then perform inference is a step of asking questions. Okay, so this is a part we are going to ask the model, and this part is to use the torch function to actually extract the logics and find the answer span, and then decoding the answer with the last step. Okay, so you can always check which is the exact definition of each sentence. So I'm just going to quickly pass to the test part. So in this case, I already predefined both the question and the context. So this model will do one thing, asking this question with the context that we provided, and the model will output the answer. Okay, what is machine learning? A field of artificial intelligence. We can see here, machine learning is a field of artificial intelligence. This is quite an easy task, right? Okay, let's expand this example. Now we involve also Gladio. Okay, first of all we install the dependency, and we see, okay, this code is almost the same as the previous one. The difference is that now I involve one of the function to script the Wikipedia website about the linear regression. I'm going to ask some questions around this topic. I'm going to see how it performed. Then the BERT question answering is similar to the previous one, and also the inference part. Okay. So now, but the inference part, you see the description is ask a question based on the context of linear regression Wikipedia article. Okay, this is just to mention how the question and the context will be linked. Then we launch the interface of Gladio. So let's try one question. What is linear regression? Okay, and we submit. It is a very beautiful AI. I really like it. And you can see also in the large language model playground and the different sources, you can see a lot of application of Gladio. Okay, so let's see how it performs. It's not very quickly. We get an error. So I think it may be influenced by the code that I run after it. So I'm going to rerun this part and launch the application once again. Okay, so I actually deleted my runtime, cleared all the information by here. Okay, disconnect and delete runtime and rerun it. Okay, so I suggest you when you test this notebook, just make sure that you test each part individually. Okay, when you finish this part, you go to the next part, not running everything together. So as you can see, I ask a question: what is a linear regression? A statistical model, which estimates the linear relationship between a scalar response, dependent variable, and one or more explanatory variable, regressor or independent variables. Not so bad, right? So it actually query the context that I provided is in a Wikipedia webpage. As you can see, if you ask a more advanced model with the function call to get the online information, the output will be more what can you say, will be more abundant. Okay, the context will be longer, especially when you adjust the temperature. I'm not adjusting anything here. Okay, I just load the model and run it in a plain vanilla way, just quickly to view the effect or how the result is going to be shown. And you can see it is like a quick query, right? Not necessarily quicker than you just search on the browser, okay? But it is doing some of the query. So let's try another question, okay? What are the metrics for evaluating linear regression? Let's see how it goes. As you can see a shadow bar to show the progress. Okay, not so bad. Mean squared error. Okay, is one of the metrics to evaluate a linear regression. You can also have R square and different metrics. Okay. Okay. So far so good. So very quick um, view of the birth model to query on the context. Okay, you can also try on your side. So now let's try GPT-2. Okay, in GPT-2, the basic structure is also like querying the birds. The difference here is that I now add a widget, okay, to actually make it shown in the output window, so I can input my my query, my prompt. But as you can see, if you use the Gladio, it is more user-friendly, right? Much nicer to look at. So now here, GPT-2 is different because you do not need to give a context, okay? So let's try here. Ask the similar question, okay? What is linear regression? And we click get answer. And we're going to get a response. Yeah, you see, what is linear regression? The answer is that linear regression is a way to measure the relationship between a given variable and its value. It's a way to measure blah, blah, blah. And as you can see here, it keeps repeating itself. Okay, it is a way to measure the relationship, and it is a way to measure the relationship. It goes on and on, right? And let's try another question. What are the metrics to evaluate linear regression? Let's see how it goes. Yeah, you see, the first metric is the number of times the regression is repeated. And not what I was expecting, right? The second metric is the number of times the regression is repeated. It is like repeating a sentence and only change some words. It is quite fun to test, okay, just to understand. Okay, GPT-2 actually it has been trained with a different data set, different structure, and how it decipher your prompt in the model and give you a response. Okay, it's quite different from the previous one. So let's try with Gladio. Okay, so basically in Gladio it will be shown better like this. Okay, at this part, let's see. We actually expand some of the parameter like temperature, maximum length, and so on. Okay, so my original hope is that we have this is like a navigation pane. Whenever you see, like in Hugging Face or in other place, you can see for each large language model, if you want to chat with them, you're going to see this parameter adjusting pane. Okay, and you can try to change different parameter. Okay, and since the code was mostly generated by GPT, the interaction with GPT and the refinement. So if you go to the GPT-2 model documentation hosting Hugging Face, you are going to see here, like the model generator, this function. Actually, you do not have so many parameters. So for GPT-2, I am not sure if All these parameters will be taken by the model. But of course, you can do different tests. You can either follow more strictly with the documentation, or you just ask GPT to generate this function. Both ways are fine, okay, to make it work. And if you want a more robust test, just try to modify this part. Okay, this is not a final and rigorous version of the output generation function. Okay, it is only for your reference. Okay, so let's see here. I do not change anything, okay? I say again, what is a linear regression? A good thing about the Gladio is that once you click enter, the model goes on to generate, okay? You go to the phase of inferencing. However, if you use a widget or something else, you need to click the button. Okay, you need to put more focus on the design of the interface. But Gladio seems much better and easy to get on. Okay, so what is linear regression? Yeah, it is more or less like before, and you see here it kind of repeated itself. So let's see, we actually shorten the response size, max length. Okay, yeah, it is much shorter, but you can see the repetition is inevitable, right? So let's try what are the metrics to evaluate linear regression. Okay, let's see how it goes. Yeah, it is like the previous one, right? Now we only change the interface for a user-friendly interface so we can test. Okay, so now here we tried both the BERT and the GPT-2 model. It is quite interesting that you play with different model to understand how, for example, before GPT-4 and more advanced model, when we look at the older model, it's like that you examine the history of the large language model and you can get a better sense. So an easy way is to get the code fast and then try it by yourself, feel how it adapts to your user case. A more Another way is to take more time to read the documentation, read the published paper. It will take a lot of time. If you are not really doing research about the models and you focus on your user case, I would recommend you to test it in different sources. Okay, there are also some sources where you see the models are hosted in a website. You can try it, or you can try it here with this notebook and adjusting some of the parameter and test it out. Okay, so you need to understand what you really want and what is your use case, and if such test is useful for you. Last thing is that I'm going to show you this failed example about the other model is a GPT-J 6 billion parameter version. Okay, it exploded because the RAM. You see, the free tier Colab has a 12 gigabytes of RAM available. It quickly just explode to go over the RAM, so the loading is not successful. Okay, you can try if you have enough resources, computational resources. Now let's take a look at the note. The note is generated by GPT with referencing of the different sources. Of course, it also queried the Wikipedia and so on. So if you want to try to take a closer look at how it is designed, you can check it here. But a rule of thumb, when you see the models, if you do not care about the design, the structure, the computational, how can I say, the structure and so on, you just check the parameters. The bigger the the more the parameters, the larger the model, the harder it is trained, the more computational resources you need to train, fine tune, or even doing inferencing. Okay, it's just a quick rule of thumb. And here we also have a comparison table like I introduced you in the beginning. So primary use case, let's check about GPT-2. It's about text generation, language task. Okay, how about BERT? It's extracting Q&A, understanding task. And if we are using it at home, for example, I would prefer to use the BERT model because it you can set the context, right? You know, if you want to query a knowledge, maybe Wikipedia is a quick source. If you want to query a research paper, you can just pass the PDF and get the information and ask the model. But of course, its performance is much, much less ideal or less advanced than the later model like GPT-4 and so on. So we should have fun to test all the models, which this tutorial is useful for you. And if you have any question, feel free to ask me. If you like my video, just subscribe and see you next time. Bye bye. Hello everyone, welcome back to my channel again. Now I'm going to share with you some of the test results of GPT-4o and GPT-4o1, two models. So on the left-hand side, we have the GPT-4o model. On the right-hand side, I have the GPT-4o1 model. So I see a lot of online comments, analysis about the new model. There are some assumptions about how this model is different from the previous version. Basically, one assumption is that it has a chain of thought. The chain of thought, we have seen it in the prompting engineering, is a technique to guide the large language model to follow a reasoning process when dealing with hard problems. And there could also be the chain of thought in the agentic workflow. So now here comes the second assumption that the new model actually has agentic flow in the backend. So there are some agents to organize the workflow and to provide a more detailed response. So at first, you can see on the left-hand side, the GPT-4 model will just break down the different approach first to suggest the approach and also give a sample code for front-end visualization. And yeah, I say I want to build it. It will give me more guidance on how to run it in Colab. So I'm not going to evaluate the intermediary results like this one. Okay, I'm going to go straight forward to the end. So basically, as you can see here, my prompt is to build an app to dynamically show the neural network working process. Okay, so it said that there are some features. I'm not going to every sentence it says, okay? But eventually, here, the first workable result is this sample code. And I say, okay, please help me build it. And I want to use Jupyter Notebook, okay, because I want to run it in my Colab environment and also local environment. And here it goes to install dependency and so on, like the routine job. Okay, also give some the detailed code. Okay, so also next step suggestions. So let's now see how the GPT-4o1 works. I give the same prompt, but when I gave the first prompt, it actually breaks down this. It's called a reflection. In my interface is in Italian because of my geolocation. But I can see it's like internal recursive thinking process. Part of it is breaking down this task and also to build a chain of process. So either it's a chain of thought design or agentic workflow design. It works well and make sure that there is a plan to go. Okay. So let's see, clarifying the request. Okay, mapping out the request to an app to dynamic blah blah blah. Pulling together suggestions. Okay, and highlight the visual aids. And actually understand when I said dynamically to show this process so it understands correctly. Evaluating options. Okay, it's good. Then assessing neural network tools. Yeah, so it said deep background of interactive visualization. So it's still checking if different tools will meet my demand. Eventually, it will evaluate the options. So I'm not saying that it will evaluate everything in the end, but in every step you see there are some checking. So I would suppose that in each step there is an evaluation process to actually make sure that each step is more cohesive. Okay, can work in more streamlined model, streamlined way to the end. So let's see. It actually says, okay, if you're interested in an app dynamically show the work, there are some options. Yes, of course, I know there's a playground of TensorFlow, and also there are some useful websites for me to try. If you are interested, please try it because some of the playground I think is built very well to help you visually understand the neural network. And also it suggests, of course, educational website. Okay, they have a very good educational resource. And consideration for the app. Okay, it just gives some simple suggestion. So I would say it will give a more approachable, more easier way to get what I want. So I can use these third-party resources. Then it gave me some indication how to build the app. Okay, so it makes sense, right? So instead of spending a lot of time to build the dynamic display of neural network, why not use third-party resources if you want to learn something? Makes sense. So let's see here. Yeah, I say help me build it, so it starts to building it, and the dependencies and so on. And you can see it actually breaks down to different steps. I mean, if you change your prompt, I'm sure the result will change. For example, you want the model to give you one code block instead of individual blocks. Okay, but here I think from a learning perspective, it helps me to learn this um, deep learning algorithm very well. So it breaks down to say, okay, these are the activation functions, and define a neural network, create interactive widgets, and so on. And okay, here is the first time we display the interactive plot. So it keeps on going. Okay, here we already see some results. I'm going to show you in the collab later. Then it says visualize a multi-layer neural network. So it goes one step beyond. As you can see, these all functions are about a two-layer neural network. So previous one, we could assume that it is about a one-layer neural network. Okay, so it goes on and on, just increase the complexity of the code. Then we see here, it actually is saying visualizing decision boundary, one of the important concepts to visualize. Yeah, it actually expand to different secondary topic like decision boundary, right? Let's see. Okay. And enhancing the user face. So eventually, after displaying one layer neural network, two layer neural network with all different activation function and setup, then it goes to the decision boundary. Eventually, it goes to user interface. User interface enhancement would be very important to help the users to see. Later, you are going to see how it is enhanced. And eventually, there is an additional option to turn it into an app. This is out of my expectation. Okay, so now let's check. On the right hand side is the code, left hand side is the Viola app. Okay, so let's go through the notebook first. First of all, this is the GPT-4o version. You see here, we can have the display of the neural network. Okay, and also here you have the second option. You have a run button to run the forward pass. Okay, it's called a run forward pass. It's just to simulate the neural network for you. Um, if you run this code, you can change it. It will produce a new picture after it. Okay, so basically it works. Okay, and I just reconnected to my runtime just to show you. You see when I change the input, it's called input neuron, hidden layer, hidden neuron, sorry. And you can see each time you click a different parameter, you have different neural network, right? So output neuron, let's say we have 5, yeah. So this is a neural network with one hidden layer. It simulates very well. Then we see the part 2. As you can see here, when I click run this part of the code and click the button run forward pass, there's nothing shown. Okay. So I finished the part about the GPT-4o. Now let's check GPT-4o1. Okay, so we need to install the different dependencies. Okay, and this function does not work. I just skip it. Okay, this line does not work. I skip it. And as you see the result from GPT, okay, I pasted everything here. I just rerun the code to make sure it works. Now let's see. If you change the weight, actually the sigmoid function changed its shape, and when you change the bias, okay. So it just shows you that how the activation function will change in shape, so you can have you would have different outputs, okay? And if you change the activation function, you are going to see different results. Works very well. And you see it does not just create another graph. It actually changed the original graph, so you can see it dynamically. Looks good. So let's keep going on to see the more complicated way. So this is a two-layer neural network. If we change weight 1, bias 1, activation function change, we change weight 2, bias 2 of the second layer. Yeah, looks good. And if we change to another function, yeah, looks good. I mean, looks good, it works when I change the parameter. But if you really want to 100% to match to a specific model, to actually know the calculation result is 100% correctly displayed here, review all the code. Okay, now I just quickly go to the next part. Always pay attention to the different packages, because in Colab environment, some packages are defaultly installed. If you are going to run it in a local environment, you need to install some of the packages. So let's go on to the next part, decision boundary. So basically, decision boundary is very useful in the classification problem, because in the boundary it is a fuzzy area, I would say, because you cannot separate the two, let's say, two items, okay, or two objects, okay, because let's imagine it's an object with different traits, different features. On the line, you cannot separate them correctly, or you cannot see much difference between two groups. The further away from the decision boundary, the more clear the picture it is. You can separate the data points to different groups. Yeah. So whenever we change the parameters, then how the data is fed to the activation function and create such a decision boundary. You can see it in this graph. Then let's go on. Let's see. Yes, in the later part, we have a two widgets choice in the same output. You can see here, if I change here the weight 2, actually weight 2 on the upper hand side also change, okay? It gives me more flexibility of manipulating this display. Looks good, okay? Uh, Only issue is that in Colab environment, you cannot initiate the Voila app. So let's switch to the local machine to see if the app works. Now let's take a look at the results in the local machine. On the right hand side, I open the notebook. On the left hand side, this is the result when I launched the Voila application. One thing I need to mention is that you see the notebook I saved in Colab cannot be directly run utilizing this application, because let's see in the end, it's very important that whenever you run this notebook, you input this command in the terminal, it is going to run all the code blocks in the notebook. So like in Colab, let's see this original version. If we are going to run it, it will go through each block. So if some of the code is going to run well in the Colab, it will not certainly run well in the local machine. So always pay attention. So I created this clean version. I just delete the unnecessary reinstallation of the packages because I already installed previously. Okay. If you run it for the first time, of course you can put it here. But if you run it the second time, it will go through the installation again. It may drag down your runtime. Okay. Increase your runtime and drag down your efficiency. So as I cleaned up this notebook, I delete or I canceled some of the unnecessary parts. Okay, so the app will run through every block. Okay, we can try to refresh it here. So I think I need to restart the Viola app here. Let's restart here. So now we inserted the correct command, Voila, with the notebook name. Okay, the clean version, of course. And we click enter. It will start running the code. As you can see, it will open the browser. I'm going to close the previous version. So as you can see here, it will execute each code block one by one. So again, important thing, because I already modified a lot of things in the clean version. So basically, I canceled all the installation of the package if I already installed. I canceled some of the unnecessary confusing code, like the code to be run in Colab environment, right? Canceled everything, and this app works to execute all the code that can be run locally. Okay, and you can see here, it will also give you some of the indication like this one. this notebook is not trusted, okay, and so on. So let's wait for the final results. It will execute each block one by one and eventually show the results. And after refreshing several times, I get the result on the left-hand side. So one suggestion, when you see the left-hand side stop at a certain step and you are sure the code has no problem, refresh, you are going to get a result. So basically, this app has shown everything that we have seen in the Colab notebook, and you can see it is very user-friendly. Okay, you can change the different parameters. You see the activation function, the change of the result. Okay, so one important thing, remember the activation function, okay, is going to take the weight and bias calculation results and provide this output. Okay, if you are interested to dig into the different activation function, please check their theory background. It is very useful for you to understand neural network. Okay, so let's back to focus on the app itself. Okay, you can manipulate everything, and you are going to see the different result here. It is very clean and well designed. Okay, I'm going to say I'm really surprised about the new model for this specific task. But as I see, some of the OpenAI employee already published in Twitter. They said we cannot expect this model to perform always better than the GPT-4o because on some specific task it may be inferior. Okay, I have not yet tried those kind of tests. If I find anything, I'm going to share with you in the future episodes. Okay, so basically, quick wrap up. So today we tested the GPT-4o and the GPT-4o1 two models to do the same task. Of course, GPT-4o has some working code, but the overall performance GPT-4o1 get a more robust design of the whole process and to really break down the task and provide a working code, and it works very well. Okay, this is a quick wrap up. Please try this model, and if you have any question, feel free to ask me. If you like my video, please subscribe, and see you next time. Bye bye. Hello everyone, welcome back to my channel. In this video, I'm going to show you how to evaluate the podcast generated by Google Notebook. I'm going to do the following steps. First of all, I get to the text information I need. Is this economic bulletin issued by European Central Bank? And I insert into the ML notebook, inserting the source part, and let the notebook generate the conversation. So would be a podcast style voice recording. Then I'm going to get the transcript like you see on the right hand side. Then I put it ChatGPT to evaluate the whole recording. And eventually we are going to see the comparison between the two text blocks. So first of all, if you want to do such kind of test, you need to first find the text information you want to analyze. This one, I choose this page because from the URL, we have the text information of the whole report ready manipulated. And if you insert in ML Notebook, whenever you add a resource, see here, we can copy the link directly to load it. After loading it, we can see notebook guide, and we have audio overview and a summary. So today my interest is to analyze this audio generated. So if I click load, it will start generate. I'm going to show you the result right hand side. So after generate this audio file, I'm download. Then I go to my Microsoft Word interface, and I can use the transcribe function, okay, to load this audio file. And as you can see, after transcription, you can see all the text information. Of course, if you have other tools you can use, see how it goes. So now I have the text block originate ML go, and now we are going to evaluate this podcast quality with the original text as shown here. So first of all, I save transcript audio file and ask the model to wait. Okay, so basically you can see here I text information and ready to use. Then I copy text facial websites. I ask the model to find similarity, find difference, highlight any statistical number in a table. So this is the whole text information. Of course, it's much longer than podcast text information. Now, here we see this is a detailed comparison between the two texts. Text 1 is the transcript, text 2 is the economic summary. You can see that the first block is similarities, second differences, the third is highlighted statistical information in a comparison table. Let's just say in the first block of the similarities, we can see the descriptions are quite close to each other. Like you can see here, with the transcript discusses the growth of 0.3% in Q1 and Q2 2024 driven by service. In text 2, we mentioned slow growth in Q2 compared to Q1, but also 0.3 growth. So there is not very significant difference. And if we check the difference part, you see the interest rate changes in the transcript focuses on potential for future rate cuts. And in text 2, no changes in interest rate, keeping them at restrictive levels. So we can see here we either witness the hallucination of the model or the summarization capability is not ideal. Then we check the statistical part. My original intent was not to ask it to compare the economic data here. I want to see the statistical comparison between the two text blocks. Anyway, this table it presents here. I see some differences. I think it is also good, but I'm going to improve the analysis in the later part. So I was asking how is the general sentiment of the two dogs differing from each other. So I'm asking the model to do sentiment analysis. As you can see here, it starts to analyze text block of the transcript and of the original doc. For example, like this one, you see there's tone, sentiment, perspective, okay, in 3 parts. And there is the overall summarization of the difference of the sentiment. Like the transcript feels more accessible and mildly optimistic, and the official document seems more serious, cautious, and slightly concerned. Okay, and now we see how would it rate the podcast on each paragraph. The engagement level, fact presentation level, information cross-check level, professionalism as a podcaster, and professionalism as an economist. So here we see the paragraph by paragraph evaluation, and starting from the first one, we see all the metrics evaluated by GPT-4o model. Let's see. Until the end, it does a job as a data analyst, so I do not do any additional coding. So there was a bar chart here, but now since I reload my conversation history, it does not show again. Now let's see. I also asked it to offer the error bar chart. It looks not so clear. However, we have the rating table in a CSV file, so we can download and manipulate further. So I just describe further my request, ask you to improve. Okay, so this one looks much better. So we can see the general engagement level is ranging from which level to another level. And now I can see, in generally speaking, we can see the fact presentation level and professionalism as a podcast are in general higher than the other measurements. Okay, now I further improve the visualization. If we put it horizontally, we can see the different metrics compare with each other. Okay, so we see the professionalism as a podcaster has reached a higher score in general, so which means that it is more skewed to the higher level, which is what I expected. And in the other metrics, you can see the scores range is skewed to the lower range, and the span is larger. Okay, like the professionalism as an economist. So basically, some of the comments or claims are not as professional as an economist, but sometimes it can also make an accurate claim. Yeah. So with the visual, I think it's very easy to judge models. So now I wanted to get a histogram and further smooth it, and here we see the final result of a KDE plot. So as I said, you can see the different distribution of the scores and how they are skewed and which is the density of the specific score. For example, like this one, this pink line, I think is the professionalism as a podcaster, as I said before. And then we see most of the score, the average score is around 8 points, which is around 8 points, which is higher than the other categories, and is skewed to the positive level. Okay, so with these visuals, we now can say that using different models to evaluate the outputs of another model is a very good way to give us the first impression of how the models perform. However, if you could get multiple models to work on the same evaluation, it would be better. For example, if you have some free models in localhost, for example, you don't have GPT-4o, you can generate the matrix or the text evaluation information, then summarize it to a data table, then utilize Python in local environment to do the analytics. Utilizing ChatGPT or other online tool is going just to speed up your process of analysis, but I always recommend you to be cautious to interpret all the results. I wish you like this video, and just to summarize, we have a way to evaluate the outputs, especially the audio outputs of another model with ChatGPT. If you like my video, please give it a like. If you like my channel, please subscribe, and see you next time. Bye bye. Hello everyone, welcome back to my channel again. Today I'm going to do a tutorial on how to use ChatGPT. As most of you already know, ChatGPT has been a dominating AI chatbot around the world. They have a very capable models to help us to accomplish daily tasks, either for study, for life, for research, and so on. Although they have some fundamental defects like hallucination, imperfection of output, and so on, I still think it's very useful for us to understand how to use it to boost our productivity. Now we take a look at the ChatGPT 4o model first. As we progress, I'm going to introduce you to other models, but this one is the most direct, and it is now the default model that you are going to engage after logging to ChatGPT. Case number one, simple question and answering. So let's ask who is Tom Hanks? And the chatbot will give us the reply on who he is. Of course, this is based on the ChatGPT training data. And if you stop here, you have a great chance that some of the information is not accurate. So if you want to further increase the reliability of the response of the Q&A, you can go ask cross-check on the internet. This is one way to make sure that the response will have a more robust proof. So as you can see here, ChatGPT already did additional search on Bing, Wikipedia, and other websites, and eventually give you this response. And you can see also here are citations where you can go directly to the source of the information. It will make the results more reliable. Case number two, if we go on with this question, let's see, can you summarize some statistics about Tom Hanks in his career? Cite sources. And we can see now we are going into another step to understand the statistics about this person's career, and also we can see some numbers here. So this could be a quick dive into the data analytics about a specific topic. As you can see, if you ask questions with additional requirements to cross-check or to show the sources, to cite sources, you are going to get more robust response. Case number three, let's see if we can transfer this textual information into statistical table. Okay, let's try it. Please provide statistical table for the stats you gathered. And you can see now ChatGPT is running the code in its own environment to analyze the relevant information and put inside. Usually, if you already have some chat results, it will transfer those statistical information to a data table in his environment. And as you can see here, you have a tabular data display, and you can also enlarge it, expand, and you can check the whole table. Of course, some of the values, for example, this is dollar value, and then you have the count value. Some of them are not in the same standard, but you can always improve and ask additional questions to perfect these statistical information. Now, let's go to the next case, case number four, data analytics. We do not just gather the data table, we actually go deeper to the analytical aspect. Now, let's expand the data analytics range. Let's say, please compare 5 more actors like Tom Hanks, gather the similar stats, separate in dollar value data, and count data, show comparison in graph. As you can see now, ChatGPT has gathered several names like Leonardo DiCaprio, Denzel Washington, Brad Pitt, Robert Downey Jr., Johnny Depp. Okay, so it now gathered the relevant information from a reliable source. This is because I already asked it several times to cite the sources, so now in the new response, I do not need to specify it. But if you see that it is not citing sources, you can always ask it to do so. As you can see now, we have the information gathered. Now it is starting to compiling the information gathered. As I specified before, now we need to separate the dollar value and also the count value in separate table. And we can see here, it does a quick job. Show first of all the total global box office gross income of the famous actors. As we can see, the different actors are compared in this bar chart. It looks good. And we can see here, we have the comparison of the award-winning counts of each actor in different awards. So this bar chart is also organized well. You can see here is also a summary that it said that I have created two sets of visual comparison, global box office gross, and also award comparison. Of course, I always recommend you to double check the data it gathered because sometimes it may not be 100% accurate. This has been an issue of the models that we are using now. Now, let's go to next case. Case number 5, advanced data analytics. So we have already gathered some of the statistical data and we want to first of all expand our sample because we want to see more actors, for example, and we want to see a classification to see how can we group different different actors. Okay, let's try it. Expand actor range to 30, gather relevant data and categorize them according to the data you gathered. Use proper machine learning model. Okay, as you can see now, if ChatGPT is giving you two responses, because now the response of the ChatGPT sometimes cannot reach the optimum, so now there is a reinforcement learning step. It asks the user, like you and me, to choose between the response to see which one is better. So it will act as another data source for them to enhance the performance of the model. As you can see, there is a response number 1, it goes to a deeper thinking process, and response 2 already get the results as we can see here. And it stops at the machine learning model choosing, suggested the k-means clustering or random forest classification. As you can see in the left-hand side, it actually goes to, first of all, the list of the actors, gather the data, and also describe the data analytics approach, the process, for example, data preparation, and model selection, and evaluation, visualization, and so on. So the response number 1 goes into a chain of sort process. So the response looks more robust than the number 2 response. Okay. And as you can see here, it already, on the second response, it already gathered the 10 actors information, right? It only shows you the example and it will go on. Okay, since the first response you see, I can't perform actual data analytics and generate real-time graphs without current data. It only shows you the framework and do not do further suggestion about how it will do the work. So I will choose the second response. I will say go ahead. And you can see now it starts to write code to analyze the data. As we can see here, the only problem is that it only gathered 10 actors. data, reading the data frame, and normalize the data. This looks good. It's a very common approach in data analytics. And apply the k-means clustering. And you can see it uses these statistics, like box office gross income, academic awards, Golden Globe awards, Emmy awards count. And we can see we have this cluster chart shows the different cluster of the actors. As we can see, it actually separated into 3 clusters. Cluster 0 with moderate box office performance and a combination of awards. And these are the actors included. Then cluster 1 with high box office growth but relatively fewer awards looks accurate. And also high award count and substantial box office figures. Now, you can also choose to download the chart to your local environment or go on with the chart. Since the response does not match our expectation yet, let's go on to ask it. Please make sure you include 30 actors. Okay, because now we only have 10. So it starts to describe you first what it is going to do, gather data, process, and rerun k-means clustering. And here we see more actors are joining in the analytics process. Let's do a brief count here. We have 5 columns here. 5, 1, 2, 3, 4, 5, 6. Yeah, we have 30 actors. We also have the table, but as you can see, since some of the data is not available, so when you do the analytics, you will have the error. And it starts to resolve this issue to correct this error. Yeah. So now it suggests to replace the missing value with mean or median. Okay, let's see what it has done here. It actually you choose the median value to the not available data. Makes sense. Of course, you can also ask it to choose 0 to substitute the NA value. Now, let's see. Okay, the data looks okay now, and we go to see the different results. We have the cluster chart. As you can see here, the actors are clustered into 3 categories. And we also have the detailed table here. It looks good. Of course, you can also download it to do further analysis. Okay, so in this case, we expand our data set. We apply a machine learning algorithm to categorize the data. Case number 6. Now, let's summarize the information we gathered and analyzed above. Now, let's say write a summary report on the analytical results as a hypothetical data analyst called Tom. As you can see, it now drafts the summary report of the data analytics we have just done. They describe the approach, detailed steps, and the results and observations. And it also gives you the conclusion here and the recommendation. I always see this part of recommendations very valuable to give us insight to do further analysis and to see how the large language model has improved over time. Now let's take a look at case number 7. In case number 7, I'm going to ask the model to draft an email to send the information to the boss and to schedule an appointment to discuss it. So let's see. Please draft an email to send above results to the analytical team boss called Tim and schedule an appointment to discuss the analysis tomorrow 2 p.m. Now it starts to draft the email. I really like the function to draft the email because it saves your time. You just need to proofread and to modify the email, then you can send it. You can see here for the appointment, it actually added this as a text message to send in the email, and in general it looks good. Now let's go to case number 8. We ask for additional task. So I will ask it, please update my Google Calendar for the appointment mentioned. So this will go beyond its capability because it does not have the link with my Google Calendar. The model will instruct me how to add the appointment to my Google Calendar. And you could have other options. There are many tools that you can choose. For example, the GPTs created by others to perform such task. But you need to consider the more you involve the third party, the more you are exposing your personal information to the third party. So there is a tricky balance here. Case number 9. Alternatives to the uncompleted tasks. For example, as you can see here, we cannot ask GPT to do the job for us, but we could have alternative. For example, if we have the calendar file attached to our email, the counterparty could receive it and also open it to include the appointment in the schedule. Okay, so I would ask, please create a calendar attachment file for me so I send with my email. As we can see here, the model starts to write the code, although you can see the speed is not very fast, and eventually it saved the file first in its environment and will provide a link for us to download. As we can see here, the model does not successfully provide ICS file for us. This is one of the cases where we meet another obstacle using this model. However, we can also copy-paste the code to our local environment to run such code and generate the file. Or we can go to Google Calendar. In some other cases, for example, if you want to ask ChatGPT to generate a notebook file for you to run in local Python environments or in Colab, sometimes it can generate, sometimes it cannot. So you need to try and see if the model can provide the answer you want. This is part of the instability of such kind of model, and you are going to see many cases as long as you use more and more of such models. Now let's go to case number 10, coding. So in this case, I'm going to use two models of ChatGPT, either ChatGPT 4o and Canvas. So I'm going to prompt to get the code, then run in my Colab environment. So the code would be provide me with the Python code to run in Colab, getting a APL price trend, and conduct technical analysis to judge the buy or sell opportunity. Going to prompt both 4o model and also the 4o canvas model. As you see here, the display are quite different from each other. On the left hand side, you see is still the chat mode, and you see the result, you see the text block and also the code block. On the right hand side, it goes to the display of the code only. If you want to change it, you are going to see the update of the code on the right hand side, but on the left hand side, if you ask for change, it will generate a new response. So let's try first of all the left hand side code. Let's see if it works. Now let's copy the code here and run it. Okay, so there is an error about this code. I just copy and paste this error here and see if it can successfully debug. Okay, now let's copy it to Colab environment and run it. As you can see here, we have some results. For example, like the moving average, RSI, MACD, different technical analysis results. However, in the end, we still have an error here. Okay, so let's see if it can debug. So it is suggesting to change part of the code. Okay, we're going to copy and paste this part of the code and change it. Let's run it. Okay, there is still one error left. Let's try. I think this is an easy error to fix. Importing pandas as PD. Let's see how it will modify the code. Yeah, you see here it adds this line. I think the package we do not need to install again. Let's just copy the rest of the code and run it. Let's copy and do here to new code block. Let's run it. Okay, let's see. We have some results, right? We have some results about the stock price analytical signals, the basic data, I mean. But to judge the signal, it cannot give us answer, right? So in this case, it's not debugging the error. We do not have any bug to copy and paste, but we can describe the issue here. The signals are all NA, and see if it can understand and solve the issue. So this looks okay. We need to check the values, cross-check logic, extend the data range, and let's see. Well, let's check the data. Okay, and let's provide this data back to ChatGPT. Okay, so it identifies the issue is not about the code itself, it's about the data. Because during this period, there's no crossover of the moving average lines, so we do not have a clear buying or selling signal. So after several rounds of questioning and answering, I cannot get a successful result. So let's go to the right hand side. Now this time let's try the results provided by Canvas. Because I believe there should be a crossover in the dataset. The problem is that in the previous code it cannot identify. Let's see this one. Okay, so the Canvas code, first of all, it directly outputs several timestamp when there is a signal, and in general it looks more direct than the previous code version provided by 4.0 model. Now let's see, because now we do not have error to debug, let's try to ask Canvas to improve the code. Can you improve the code to provide more explanation and show detailed data? So it will go to review the code line by line and change it. You see, it's a dynamic process, and eventually the final code will be provided on the same interface. You do not need to check another chat result. It is always here, so it's dynamically updating. And when you choose a specific block, you can ask ChatGPT, okay, and you can ask it to change or explain. So the result will be presented again by changing the code line by line. Let's try this code to see if it gives us additional results. I think the package we do not need to install again, so I'm going to put it in another cell. Let's run the code. Okay, so now it provides me additional statistical information about the privacy information, and then it shows the process of calculating the different metrics in the technical trading perspective, and then plots. Now the plots are the same as the previous one, and now you can see there is a trading volume under these charts, and for the buy sell signal there are very clear description. For example, this one is a sell signal, and in general it looks good, and these are detailed data with calculated indicators. Yeah, everything looks alright, and also there is a comment here. So this does not mean that the Canvas model can always perform better than the 4.0 model. It depends on the use case. But for the use case that I'm presenting you right now, Canvas code give a zero shot best results, and 4.0 model cannot provide a zero shot best results, as you can see here. So for different scenario, I suggest you to try and to understand which model is the best for you. And of course, on the right hand side for the Canvas version, you do not need to be worried about the model to forget some of the content, because it will always go through the code one line by line, and you do not need to worry. For example, we already have a back and forth 50 rounds of the chat, and maybe some of the information is missing. So for coding purpose, at this moment, I think a Canvas is better. But if you want a conversational style, it is suggested to go back to the 4.0 model, because you can see there is a structured conversation. You can also see both the code and the textual output together. Now, after we zoom out of the code interface of the Canvas model, you can see the textual information is very limited, because all the change has already been applied inside of the code block. And for the model, you can see that the code is always with the textual information. Case number 11, writing. Now I'm going to use the chain of thought model. It's called O1 preview with the canvas to write a catchy song. I'm choosing this use case instead of the coding, because coding task for preview always involve in a complicated thinking process. For a specific code block, it will take a lot of time to debug. Of course, you can try. But now I want to highlight is that the preview O1 preview model is going to think more than the other. And for the canvas model, you can change the part you want dynamically. So let's try it out. So I'm going to say, write a catchy children song about weather. Okay, and we prompt both models. You see the left-hand side, it goes into the thinking process, two-step, right? Creating lyrics and crafting the melody. And you can see it is well written. On the right hand side, we can see there is a verse and a chorus almost similar, but the right hand side seems each line is shorter. Okay, so for the left hand side, we can see it took some time to think about the steps, then give you the result. On the right hand side, it gives you results directly. So if I want to change part of the text information, I can see, for example, I choose this part, I say make this part longer. Okay, and in the canvas interface, you can see this part already has been changed to a longer version. Or in general, I want it to shorten the whole song. It will do rewriting of the whole song from the beginning to the end, right? And if we go to the preview model, we say change a specific part. We need to copy this part. Let's say change verse 4 to longer version. You will go to thinking, extending the verse, elaborating, expanding, and you see there are several steps under the hood of this model, and eventually you see the results. And you can see verse 4 was rewritten in a longer version. So let's see, make the song shorter. Yeah, then we have the shorter version. So this is a very simple task for both models. But if you want to do a project, my suggestion is that you can use preview model to give you a structure of your project, either to design an application or design a website and so on. But for the canvas, you will use it for like a coding, like a creative writing, is more convenient. Since if we go to the detailed example of preview to build a project, it will involve a lot of detailed steps. If you are interested, just leave a comment. In the future, I can make a video about it. At this moment, I just want to let you know the characteristics of the two models so you have a better sense. Case number 12. Now we are going to look at the case of using ChatGPT as a shopping list compiler. So for example, now I'm going to prompt make a shopping list of 1 kilo eggplant, 1 kilo rice, 1 kilo beef, 2 kilo apple, 10 kilo oil, 0.5 kilo bread with emoji. Let's prompt both the mini model and the full model. The reason I'm showing you these two models is that the mini model is a smaller model with a faster response, but the full model is the flagship model for ChatGPT at this moment. And we can see here both give results about our shopping list, but if you paid attention that for mini model it actually gives a faster response. So I would suggest you to use mini model for some smaller tasks where you want faster response, and full model you may use full model for more complicated tasks like coding and so on. You might have already noticed for the O1 mini model, for the preview model, you do not have chance to upload attachments. However, for the 4.0 model, you can do that. So you can interact with your documentation like PDF, like Excel, like picture, and so on. So you need to know that each model have different characteristic. You may interact with your chat information with different files, and the way you interact with the chat result, like a Canvas and the 4.0, are quite different. And considering speed, the O1 preview model, the O1 small model, and the 4.0 model are all different. So please choose the models according to your task. The reason I'm showing you this shopping list example is that now whenever I go to supermarket, I find it sometimes very interesting to try these ideas with a large language model. Although it may not be very direct, like if you have already a shopping list application, but I think why not try it from time to time to see if it can help us with daily life tasks. So in this video, I have introduced you several use cases. For each use cases, we can expand for a larger group of use cases. So in case you are interested to explore some use cases, please leave a comment. If you like my video, feel free to share it, give it a like. And if you like my channel, please subscribe and see you next time. Bye bye. To change to some easier topics like statistical learning or supervised learning for most of the cases.